Hey, Cassandra. Hi, Josh. How are you doing? We're going to start off doing some review, and it's going to be a lot. Our goal today with this advanced review session is to do multiple questions. Just keep asking question after question after question. You get the theme of the review. But I do want to point out, let's over to the main screen and just mention this. So let's head over to the main. Abby, great to see you here. Let's go to the main screen and check this out. Okay, so if you notice right here on the office hours, let me put a timestamp in here. 3:20, where to find topic reviews. I think a lot of people know this on the channel. Every live stream we do is here afterwards. So if you want to go and check out where we did kind of a review going over the interpretations, I think this one was, you can see all the topics we did right here. So I'm just trying to do different types of things. Allison, great to see you here. And you can see what we did right here, degrees of freedom, interpreting confidence roles. So that's a slower review where we go through the steps. Then you've got the review part 2 right here where we did, I think, output, or what was it? Let's go right here. Solving. We solved each one. Oh, we did the formula sheet. So you can see here we did the formula sheet. We went through each thing and we talked about doing different tests, reading off the formula sheet and how to understand what's on the formula sheet and understanding it. Remember, we're kind of covering the whole like a month and a half. Fran, great to see you here. And then last but not least, we have the exam 3 review extravaganza, which has the Kahoot on it too. But we did things like power. We did things like type 1, type 2 error. And so can we go over errors? We can. We can do, and that's the goal of today right here, is to do as much advanced review as we can. We're just going to do a lot of questions. So today is going to be a little bit quicker. Does everyone see that right there? How do you solve part 3, number 1 of the practice exam? If you want practice exam questions, and we could get to that, Josh, I think. But did you know, that's the wrong thing. Did you know that on the review page, there is a video for each practice test question? How does that question start out, Josh? Like, what does it say for that question? We could go look for the practice exam question here, question 3, which is going to be this one right here. Wait, it's not that one. It's question 2. A researcher believes that British men are shorter on average than men in the USA. So this is the research. It's the 2-sample t-test right here. So if we go down here, testing 2 independent means, this video right here should be, there we go. Does that make sense, Josh? We can go over this, but I just want to point out that I've made a video right here going over each part of the output on it and how to understand what the output's showing. For question 1 right here, what type of problem is this? So that's actually, we could start doing some example questions of that right here. Are you talking about this right here, Josh? Is that the one you're talking about? The which type of problem is this? Is that the one right there? We'll let Josh confirm in the chat. Is it question 3, part 1, which type of problem is this? And that'll be a good place, a good jumping off point to kind of do more advanced review of this. And that's kind of our goal today. Is that the one you're talking about, Josh, right there? The which type of problem is this question? The 3I? Let Josh on the chat. So our goal today will be to kind of do a lot of output right here. Is the first question on the practice exam asked about, oh, and that'll be question 1 right there. How do you solve part 3? Oh, part 3 on question number 1. Part 3 on question 1. Sorry, Josh, that's my fault. I reversed it right there. You're talking about this one right here. Part 3, question 1, which is this question right here with the outputs. We could start with part 3 of that question. Sorry about that. I saw 3 in my brain, straight jumped to it. So right here, you can see part 3 right there is the probability. So that's what are we trying to find right here? This is a good jumping off point, and then we'll do some more on this. What are we trying to solve for right here? This blank value right here it's trying to solve for a what? This is a missing what? Just look at the output and be like, that is a missing what right there. And Leo's got the answer in the chat. Great answers, Leo. And that's a missing what? Leo's showing how to solve it right there. That value that's missing is a missing what? And then we'll show the solve for this. And thank you, Josh, for being here, asking the questions. That's what we do. That is a missing, well, we know what the degrees of freedom are, n-1, so it's 19 for degrees of freedom. That's a missing p-value. We have the does not equals, the first one, the greater than absolute value is the does not equals test. This is the greater than, and this is the less than. So let's take a screenshot right here of this and kind of show how this would work. These are all p-values. Yes, that is correct. MG, that is correct. You are doing it. You have done it correctly right there, and we'll talk the theory right here because this is the important part. So when you see all these p-values right here, you have to understand the relationships of p-values. When we have the three p-values, we have a what test, a what test, and a what test. So what are our three tests that we have? We have three alternatives. Three alternatives. The three alternatives we have... Oh, I wanted the red line. The three alternatives we have are the less than, the greater than, and the does not equals to. So the less than, which is the bottom one, would be if you went to this arrow here and pointed to the left of it and shaded that arrow, went to the line. Great job right there, Priya, right there. So this is the area right here. Does that make sense visually speaking? Who's following me that that is 0.0033% of the curve? What relationship do the less than and the greater than have? The less than and the greater than alternative, what relationship do they have? As I'm drawing it right here, just try to remember the less than and the greater than alternative, and you can see it here visually, and there's the p-value. And then just think if you take these two right here, you wouldn't do this, but if you just did this right here, you should understand the relationship they have. They're complements of each other. So you can see the relationship they have where the greater than shades above the test statistic you found, and we found a negative test statistic right there. So the last one, which is the missing one, is the does not equals alternative. The does not equals alternative, I like to draw it this way when I do it sometimes. I do a little... Why do you think I draw it this way? I'm going to make it even bigger so you can see what I'm trying to show to you. Why do you think I draw the does not equals like this right here? What am I trying to show you by putting the arrows like that on the does not equals? What am I trying to... And great job right there, Josh. Great work. What am I trying to tell you? It shades both sides. Great job right there, Leo. And so what you do is you shade the original side that you were on, but then you shade something just as extreme on the other side. Now it's going to do that for you. But visually speaking, and it might make more sense if I draw the original one like this. So how would you find the does not equals p-value, which is, it is going to be all the blue area of shade. I don't want to confuse anybody, but it's going to be all the blue area. There you go. And I think Alea's seeing it right there. It's just 2 times the smaller one. Remember, p-values can only be between 0 and 1, so the does not equals alternative is 2 times the smaller p-value. And Josh, really great question to get a star right here. And that's good practice on finding p-values right there with missing p-values from output. So let's talk about a one sample t and kind of run through some results on one sample t's. So let's do, and we're doing a lot of questions today. So one sample t advanced questions. Please ask questions when you have them. My goal today is to ask you lots of questions. So see how many of these you can answer. If you don't know an answer, please ask. But for a one sample t, what do I need to put in here? Just explain to me, for a one sample t, what do I need to put in here? Like a one sample t means I have what? How would I get a one sample t test? Not advanced questions on the, it's like an advanced review. Like it's not advanced question, a quantitative y variable, right? And we see that right here. So we can eliminate down. Here's everything we can do for one sample quantitative variables. Does that make sense? You know what you can do in JUMP? And this is why statistical software is awesome. You can just do all of them. There you go. Here's all the one, and we're not doing a multivariate analysis right here because we have multiple whats right here. We just have a bunch of histograms. We basically did all the one variable analysis, just making tons of one sample analyses right here. This is an indicator or an identifier, excuse me. Could you go over all the interpretations? Jameson, check out the video. We're going to do interpretations here, but we do have a video just on interpretations, and we're going to be practicing that here in a moment. So check this out. We're going to stack this to make it a little more viewable. And now that it's stacked, we can go down here to one of the ones that interests us. Does anyone see, and we're going to do an interpretation right here. Let's try doing interpretation. Does anyone see like a number they'd be interested in interpreting? So these are all quantitative. We can do any of these to interpret a one sample t interval. So let's try a one sample t interval interpretation. Which one of these is of interest to you? If I go here in the center of the screen, I bet I could zoom in and get it so you can just see mostly that. Let's zoom in. Okay, good. Now which of these Q numbers in GPA? We've done that a lot, right? So let's go interpret GPA. So the confidence level really, as Rock would say, it doesn't matter. It does matter, but you're just going to state the level of confidence. So I think that's the easy part of the interval. But once again, remember, we're doing a quantitative. So this is where for Josh right there, or Jameson, This is where we're practicing interpretations. How would you interpret that interval right there? You can round everything to 2 decimals. How would you interpret that interval? This is your chance. I'm going to say the interpretations. Try typing them in the chat because you will be typing them on the test. If you are watching this right now, try typing it. Read what other people are typing. You're going to learn it by typing it. You're going to learn it by reading what others are typing, and you're going to learn it by listening to me say it. But those are great ways to learn, is to read what other people are typing. You're going to read it. You're going to listen to me say it, and then you're also going to be typing it yourself, and that's going to give you a lot of practice on what you need to do for the test. So the goal right now is to interpret this interval. We're just interpreting confidence intervals for the something. I don't even want to give you what the word is because there's an often mistake here. So what would be the interval interpretation? Don't worry, a lot of people are going to get it. Even if you're copy pasting what other people say, just try jumping into it. We are 95% confident the true mean of high school GPA is contained for you right there, just automatically. And I'm not giving out points today because the points are kind of settled. We can say I am, we are, both are perfect interpretations. I am 95% confident the true mean of the student's GPA is contained in exactly. Now, I'd like to highlight some keywords right here. And I'm going to break this apart. Great job. Riona's got 2. I am 95% confident the true mean of high school GPA is contained in the role. With 95%, there, Allison's got a 2, I think. With 95% confidence, we can say that the true mean of high school GPA is contained in the role. All those are great. I'm so sorry, Priya. I know, right? I just don't want someone to be like, they entered the sheet and then I don't want it to be confusing because I've kind of ended points, even though Mubot's still here in the background. He's always here. We are 95% confident the true mean of high school GPA is contained in the interval. Boom, boom, boom. Oh, there will be. Swing by any live stream, and you can always get a meme status if you want. I want to point to the interpretations people are giving just so you can see this. We are 95% confident the true mean for high school GPA. All these are great interpretations. And if you break down what we're saying right here, there's some key components. The percent confidence is the part where you just state how confident you are. I like to say I am, we are is fine. That's what my Pearson says. It's just I am, we are, one can be. You can use any of those. This is where the mistakes happen. The second part right here, the second part of what we are talking about, and the most common mistake I see on the test is people say true proportion. Usually, people might get a quantitative interval and they just say the true proportion of high school GPA. Hey, Laura, great to see you here. So make sure you give the context. With the one sample T, it will always be good to see her. Good to see her. Yes, that is correct. One sample T will always be the true mean. That is correct. And how do you know if it's true mean or proportion or difference between two means? You have to look at, interesting, right, Leo? So this interpretation of a mean confidence interval, correct. And we're to contrast this, so then this is where you just give the interval. To contrast what we have right here, the general question I noticed on the bonus tutor were, yeah, it's supposed to be at a 1.7, but Canvas doesn't like doing a thing. I'm going to have to correct that, and I'm very sorry. I hope that doesn't add confusion. There's a good bit of bonus, and I'm sorry about that. If it looks weird, if you think something's wrong when you get your points at the end, just let me know. I do a lot of, especially on the coming up weekend, there's a lot of grade entry, a lot of checking. Please let me know if you think your grade was misentered. In truth, I'm not going to be using Canvas to do it again. I made a Google form for the other classes, which I considered sending out, but I've already asked people to enter in their stuff. So doing it via Canvas this semester turned out to not be the best. Who'd have thought Canvas just doesn't play nice? Thank you, Canvas. Canvas, what you doing to me? To contrast this, we've got a whole bunch of output here, but let's contrast what we did because we need to know the differences. Remember, this is the advanced review, so great work. Because we don't have to make intervals to estimate the true mean, we could make intervals to estimate the what. We could make intervals not to estimate the true mean. We could make intervals to estimate the what. We don't have to make intervals to estimate the true mean. We could make intervals to estimate the what? The true proportion. Does that make sense? Why is this proportions? Why all of a sudden are we doing proportions for gender, for born in Tennessee, for a relationship, for distance from campus? Why is this all of a sudden proportions? We're seeing a lot of output here because it's categorical right there. Mubot knows the cat's right there. So it's categorical data. That's how you know the difference between, and to the person's question right there, when we do the one sample T, it's because there's one quantitative variable, hence one. And these are all univariate analysis, even though there's lots of histograms here. This is all like, let's look at GPA, let's look at PETs, let's look at PET expense, let's look at weekly hours reading, all quantitative questions, all one sample T intervals. And you notice how it says mean right there. Where to contrast that, we would look at proportions, and we're looking at a categorical variable. So take a moment right here. That's ridiculous. We're not going to look at that output. Go away. Huge table of output. Come on, we're still in major. Let's do this one right here. Can I zoom in to make it easier to see? Let's find out. Wrong button. Okay, so there we go right here. We're just doing people in the honors program. I think good. Can you see it well right there? Cool. We're interpreting this interval right here. This interval right here. This from here to here. You can round it. Like, go ahead and give that a shot. Try to round it and try to interpret this interval properly. It's probably work better. Well, if you have it seen right there, let me screenshot it and bring it over to a Word document. That way we can zoom in on it a little bit better. Just want to make everything clear so people can see. And this is your practice time. There's the thing. So there's everything. I'll disappear. So give it a shot. Be careful. There's usually mistakes on the second part. That's where the most common mistakes are. I'm just telling you about the most common mistakes I see. Usually people always say true proportion. I see a lot of like everything's true proportion. Everything's true proportion. So we're doing let me change this to interpreting intervals. So what do we have right here? Remember, we're trying to do as many as we can just to get you in the theme of just I can interpret this. I am 99% confident. Great job, Leo. There, start with the confidence level. I'm 90, and also MG. I'm 90% confident the true proportion of students in the audit programs came with the interval blank to blank. And then, what's up, Eric? We're gonna make Eric a mod. It cracks me up. Okay. So I am 99% confident that the true proportion of students who are in the honors program is contained in the interval blank to blank. And so when you say this, I want you to do the following. Leo, MG, Ezra, Riona, does what you say there, when you say it to yourself and hear you saying it, does it make sense, yes or no? Priya, when you say, I am 99% confident the true proportion of people that are in the honors program. Oh, wait. And so make sure we need, you did not. Hey, great job, Priya. I was going to throw you some points, but we're not doing points today. Priya, that is correct. Sorry, I stopped. You did grab the right, and you did proportion. Priya, that's great work right there. And it does make sense. Whenever you read this interval, just be like, I'm trying to figure out, like, what is the true proportion? Or, like, what's the actual percent of people at UT who are in the honors program? They're not currently in the grade. I'll have to add them in later. They're not currently in. Good questions, Jake, right there. So whenever you read off your interval, see if it makes sense. We're going to do another interval right now, which is the third interval. Does anyone know the only interval we haven't looked at yet? We're going to just keep doing intervals, just keep practicing, just keep writing those interpretations that when we get to them, we're just like, psh, got it. Does anyone know that third interval that we haven't talked about yet? It'll tell you which one. It'll be very specific. It'll say, like, interpret this interval, interpret that. The two sample t. Now, when we do the two sample t, which is the only interval we haven't talked about yet, the two sample t is the what between the whats. The two sample t is trying to estimate the what between the whats. We could, Abby. It's possible. Don't know yet. Good question. The two sample t is the what between the what. The two sample t is the what between the what. The difference between two means. Exactly. So we're going to go and ask people, let's do honors program. Let's do honors program. Yeah, honors program. Why not? Where's honors? There it is. We're going to ask people, are you in the honors program? And then we're going to ask people, you're welcome, Abby. And then we're going to ask people all these quantitative questions. We're going to remove the identifier because we don't usually analyze those. So here are all two sample t-tests. Why is it called two sample? Why is it called two sample? We're trying to understand the true difference between the means. Good question right there. You will lose points if you say you're trying to estimate the sample difference. We know the sample difference. We have the sample difference right here. That's the sample difference. So we are trying to understand the true difference. Does that make sense? It's always true. And let's look at our Word document. One word we can always put in here is true. You don't want to say your estimate because we know the sample. We know what the sample showed us. We're trying to understand the truth. Does that make sense? So we are trying to understand the true difference between these two means right here. And we're testing two means. Two sample t-test. We're testing two samples to figure out the true difference between them. Which one of these looks most interesting to you? Just tell me the number of the variable. We've done GPA. Here's a number of pets. Whoa, look at this. Oh, that's kind of interesting. I mean, it's interesting because it's significant. Did you see one that you really liked right here? Credit. Oh, look at that. That's a big difference. Maybe credit hours might be interesting. Which one? Do pets? We'll do pets. We'll do 2 of these because this is one of the ones I usually see the most mistakes on. So with this right here, let's grab the pet one because this is the one where there's usually the most mistakes. Look at all those pets over there. Okay, so let's look at this output. And can you interpret this output right here? This is usually where the most mistakes are on this output. So try doing this right here. We'll do another one. This is pets, how many pets you own. So try doing this, and I'll tell you the right answer. You also see it in the chat. You've got your blank interpretation up there. See if you can do this one. This is where most of the errors are. This is pets, like how many pets you own. So what is this? And so what do you think? This is going to take a moment. Remember, if you're watching this right now, try to write it out. Don't worry if you get it wrong. Don't worry. We usually throw out a lot of points if you get it wrong. So don't worry about getting it wrong. We're here to practice. I can't tell you how many people putting answers in the chat right now who are getting it right. Got it wrong a lot. If you got it wrong, I want you to say yes in the chat, like you put a wrong interpretation. So maybe you're typing an interpretation right now, but after you do that, just tell them, be like, oh, I get them wrong all the time, but now I'm getting them less wrong. Don't worry about it. We like wrong answers here. We get it wrong here to get right on the test. I'm just wasting time while you figure out I am blank % confident. You should be looking down here at it. I am blank % confident. This one's tougher. I'll help you out here in a second. That the what? And this is the way to know if you have a 2-sample t-test. 2-sample t-test will always look like this. It'll always have that difference right there. And that's where you're seeing the difference between the yes and the no. That's what Leo wrote. I'm 95% confident the true mean difference of people who do not own and do not own pets. Careful. Error, Leo. Maybe I should have said, don't worry, Leo. I would throw you tons of points. Don't worry. This is honors program. Sorry if I added any confusion. And then the second variable here is the number of pets. So no worries. This is why we're here to practice. Don't worry. That's Leo. We planned this out. I shouldn't have ruined the surprise, but we planned that out so you could give everyone some more confidence. This is the hardest one, I would say. This is the hardest interval to interpret. Usually where I'm taking off points where I'm grading these is usually this interpretation. So this is yes. Brian, not supposed to tell him that. Abby says, I am 95% confident. Now don't worry right here. This is quantitative, so we want to say we need to put mean in here. So don't worry, this is good. And Abby, great work right there. I think let's see what Priya wrote. And then MG2. Let me see MG's first. I am 95% confident the true difference of owning pets and being in the don't worry, error, don't worry. We are 95% confident. So let me tell you how to do this one because I'm seeing Priya might have it. Let me see Priya's. We are 95% confident the true mean difference owning pets and being error. Okay, so you ready? Here's how to do it. We're gonna take this is great. No one's got it. I want everyone to say woohoo in the chat because you ready? Here's how to do it. When you say this, I want you to look at this and look at where the difference is. I want you to say, I am, give your confidence level, 95% confidence. I love it. Yay, we failed. Confident. Don't worry, you would still get some points. You would still get points. It wouldn't be a 0. So you got some points, but we're going to get all the points right here. I am 95% confident that the true difference between people who are in the honors program and people who are not. Does everyone see right here? This is the portion. I am 95% confident that the true difference in people who are in the honors program and who are not in. Do you see what's subtracted? In the mean number of pets they own. Because this right here is the quantitative Y variable of interest. We were measuring how many pets do you own, and the categorical way they were split up was on are you in the honors program. So let me repeat that and just read it across as is. Read it like a sentence this way. I am 95% confident the true difference between people who are in the honors program and people who are not in the mean number of pets they own, because that's the quantitative Y, is contained in the interval 0.33465 to negative 0.34867. This is a 2-sample t-test. Yes, that is correct, because we took a sample of people who are what? And Abby, great work right here. We took a sample of people who were what and of people who were what. Let me try to do that for you right here. We took a sample of people who are what and a sample of people who are what. The true difference. Sorry, I'll fix it up here in a second. True difference between blanks that are, and then we could say group 1 and the true difference between means. I said means later on mine. I'm 98% confident that the true difference between means true difference. Oh my gosh. It's easier when I read it. I am 95% confident that the true difference between people who are in the honors program and people who are not in the honors program in mean number of pets they own. See, even I have to take a moment right here. You're saying, Brian, come on, you teach the class, man. See, even I got to take a moment right here. I'm trying to write the blank interpretation for everyone right here. So if someone puts it in the chat, that might help it too. I am 95% confident that the true difference between, let's say group 1 and group 2 stop in mean blank. I think that's got it. So I think that's the interpretation for this one as a blank thing. We can unbold the true. I think that works. Let me see how this works as a blank for you to fill in. I am 95% confident that the true difference between people who are in the honors program and people who are not in the honors program in mean number of pets they own is contained within the interval blank to blank. Does that make sense right there, Priya? Does that help out? I am 95% confident that the true difference between people who are in the honors program and people who are not in the honors program in mean number of pets that they own is contained in the interval blank to blank. We'll do another one right here in a second to practice, and I think we got some right answers. Yep, that's the goal. That's what we're doing today right here. We're just doing question after question after question. Keep asking, can you write a structure for it, and just practice. The biggest thing to know, and we're going to switch it up right here, so careful. I'm going to switch it up on you. Ready? Let me copy paste this into a new document, and let me go back to the original and go back to the blank interpretation. Okay, so there we go right there. Okay, so what I want to do right here is I want to try to switch it up on you, and I want to try to not trick you, but make sure you know which one to use and when. Does that make sense? So the goal right now is I'm going to pick one, and I want you to know which one to do and why, okay? So try this one right here. And I'm just going to pick one at random, and then your goal is to interpret this properly. I'll show you cheat sheets, and we can do that, but try to interpret this interval. You ready? Okay, try to interpret this interval properly. So try to interpret this one. This is the goal now. Leo and Priya tied on the hours. So try to interpret this one. I'll give you the answer here in a moment, but just take a moment, see if you can interpret it. Don't worry if you get it wrong. Remember, everyone was getting that last one wrong, so if you're getting it wrong, you're here to practice. If you're getting everything right, then study for another class. But don't worry, people are getting stuff wrong, so that means we're learning. The more we get wrong, the more it shows we are learning. Does the amount of time spent reviewing interpretations represent the amount of questions on the test on interpretations? Kind of, sort of. I'm going to do a conceptual thing right here. Good question right there, Ezra, because the whole interpretations are not everything on the test. But let's say instead of building a 95% confidence interval, I built a 99% confidence interval. Brian's interval would be what? Brian builds a 99% confidence interval. The interval is more precise. How do I spell precise? The interval is less precise. If I build a 99% confidence interval, would my interval be more or less precise? Try answering that right here as I read these interpretations. I think people are getting it. I am 95% confident that the true mean credit hours this semester is contained in the interval blank to blank. I am 90% confident the true mean of credit hours is contained in the interval blank to blank. With 95% confidence, when we say that the mean credit hours this semester is contained in the interval blank to blank. Exactly. And what people are noticing is this is a one sample T. You just ask people, how many credit hours are you taking? And if it's a quantitative question, you'll say the mean. Now, don't say proportion here. Very common to say. And remember, proportions, what's another way to see if these are proportions? Not saying they will always be. If you build a 99%, I'll show you. I don't know what I have up in R currently. Watch this. You can see it. I can do it quickly. if we build a 99%, like if I go here to t.test, oh, I don't know the argument for it. Let me do it in jump. If I build a confidence interval, I'm actually going to use jump, and go to analyze distribution and do age, and instead of building a 95, I build a 99, and people's interpretations were correct. I'm 95% confident the true difference between, oh yes, that RNA, that looks accurate. Oh, this one doesn't do a difference right here, Abby. This one we just did was for just the credit hours. We didn't have two groups. I just want to show you, Abby, right here, the difference between the outputs. This is what the 2 sample T output looks like, and this is what the 1 sample T output looks like. When you have the 2 sample T output, no worries, Abby, good stuff right here. The 2 sample T output will have the 2 groups right here. Does that make sense? You have like a yes and no group because there's 2 means you're looking at. And then the 1 sample T output just has 1 mean. So this is the yes minus no difference right here, the difference between the 2 means. And this is the 1 sample over here. So really good practice. And then you'll just say, for this one, I am 95% confident the true mean age of UT students is contained in the interval 19.5 to 19.65. If we go right here and we make a 99% confidence interval instead, the interval, and I want you to look at it, it went from 19.5 to 19.48. It went from 19.65 to 19.67. The interval right here got water. What did the interval do? So we went from a 95, and this is some concepts right here. Wonder what the oldest? I've had students in their 60s. None in their 70s, I think. When we go from 95 to 99, the interval gets what? The interval from 95 to 99 gets water. And I think Barrett's saying it right there. Barrett, that is correct. The interval gets less precise. The interval got wider. And this goes back to our concepts of, we're going to the t-distribution to look at it. And don't worry if you got it wrong. If we build a 99% confidence interval, it's going to get wider. And think if your friend gives you a wider interval. That wider interval is what? Less precise. So you can see it right here with the applets. The applets aren't on the test, but we're just doing it for a concept. That when we go from 90 to 95, notice what happens to the area on the curve. You're shading more of the area on the curve because you're also more what now? When you go from 95 to 90, you're more what in your interval. What has changed about this interval from 95 to 99? We are now more what? And I think Leo's getting into it right there. We've increased our confidence, and that increases the wideness of the interval, but also becomes less precise. The interval is becoming more confident and less precise. What is one way, and we're talking just interval concepts here for the moment, what is one way mathematically that instead of just increasing the confidence level, we could make our interval more precise? Like, let's take the following interval right here, which the z-score controls the confidence level. What is one way we can make our interval more precise without messing with the confidence of the interval? Increase the sample size. Increasing sample size will decrease the margin of error right here. So it's kind of good. The whole test is non-interpretations. There's a lot of theory on the test. But if you increase the sample size right there, that will make the margin of error smaller. To double it, to decrease by a half, the margin of error is 4 times the sample size right there, Leo. I don't think that's on the test, but good stuff right there. If we increase the sample size, we decrease the margin of error. Decreasing the margin of error means it's more precise. What we're saying is increasing sample size makes an interval that looks like this to look like this. And let's do some interval quickie questions right here, some quick interval questions. So we just did a lot of interpretations. We might do more here in a moment, but let's do quick interval. Okay. Let's take the following interval. I have a hard time solving for confidence intervals. Oh, yes. Oh, they're tricky. They can be tricky. Like if we were to take, oh, darn it. Well, do we show up? I'm trying to think how we do the questions on the test. If you had a confidence interval that went from, let's say, this to this, and you're trying to estimate the true proportion of UT students that are in the honors program, what is the margin of error of this interval? And then let's talk about how to do it. And I highly suggest on your scratch sheet of paper, drawing out, thank you, Leo, all the good review stuff right there. How would you solve the margin of error for that interval? So that is saying like I am 95% confident the true proportion of UT students who are in the honors program is between 12 to 18%. And Priya's got it right there. It's 3%. A very common error right here is to do the full length of the interval. Great to see you here, Nathan. The interval, if you go from the lower bound to the upper bound right here, so there's the lower and the upper bound, the margin of error is always half the length of the interval. So the margin of error is half the length of the interval. So when you think about a margin of error, just think, go right here. Now here's a tougher question, and this is half the length. The formula is going to be 18 minus, it's not a minus, minus 12. Don't worry if you do it backwards because you're just doing half, and then you would just look at the positive number of 0.03. This is a more advanced question. What statistical notation value is at the center of this interval? More advanced question right here. You can tell me what value is at the center, but what notation is that? It's the estimate of the center of the interval for this. So think about this. What is used to estimate the truth right here? That is the value of it, correct? And that is what? It's not mu. Because, and don't worry, I might not have said it. It's not mu. It's because that would be for mean, and that'd be true mean, which would be what we would estimate with the interval to estimate the true mean. This one is not y bar because that'd be for means. Don't worry, like I said, I'm gonna do some advanced questions right here. The center of this interval is p hat. Because, and I said it a little quickly, I'm trying to estimate the true proportion of students who are in the honors program. So what's my best guess of the true proportion? The sample proportion. Does that make sense? So the sample proportion is at the center of the interval, and this is the interval we are doing right here if we got this output. So there they are side by side. P hat is at the center of the interval. Yeah, and don't worry, right there, I did it a little quickly, but the center of the interval is either going to be y bar. So here, I'll just show this. The only options you would have for the center of an interval would be, if you are doing the one sample proportion, the center of the interval would be what? This is a little more advanced today. Doing a little more advanced, like kind of thinking through stuff. If you're doing proportions, the center of the interval would be what? If you're doing proportions, the center of the interval would be what? P is the truth, which we're trying to estimate. P hat is the sample, which is what we learned from our sample. The center of the interval here would be P hat. And then go with this theme right here. If we're trying to do a quantitative, the center of the interval for a quantitative would be what? Just a quantitative. The center of the interval. Well, so like when you make this interval right here, this interval is made via p hat plus or minus z star, and p hat is the center of the interval. So the equation, which is off the screen, we don't want to do that. The equation shows that p hat is the center. So the next one here is y bar. And if you look at the equation for this one is y bar plus or minus. Notice how these things are the center, and then after the center, you would have with it a margin of error. So the margin of error is created after the plus or minus, and the center is the best estimate of the truth. So the rest of the interval is just a margin of error. But when we try to estimate the difference between two means, so this is the diff of two quantitatives, or difference between two means. Think about this. What is our best guess of the true difference, which goes at the center of this interval? Well, once again, we can look at the mathematics of this to see the start of the interval before the margin of error. And the start of this interval, when you look at it on the equation sheet, is going to be the difference between the two means. Does that make sense right here, everybody? Once again, I'm doing a little more advanced, a little more theory to hopefully help out with the understandings of it. But the center of that interval is the difference between the two means. P is your proportion, P hat is the sample, exactly. How are there only, I don't know, this is fine. A lot of review going on, lots of tests, lots of stuff. But did this help? I want to make sure I'm doing things that help. Please tell me if what I'm saying makes sense. We're probably going to do some test interpretations here in a moment. I'm just kind of doing as many things as I think could help out. But the center of the interval is what we get from the sample. Maybe, maybe not. I don't know. It's a lot of material. That's why I was like, let's jump on here. This is your last exam. Yay, Priya. That's awesome. Last exam. Let's talk about interpreting test results. So this is going to be interpreting tests advanced practice. And then we could do like a review of this afterwards here, but we're going to do interpreting tests advanced practice. So get ready to interpret test results, and you're going to learn some concepts from this on interpreting the tests. Okay, so let's go over here and start running some tests. What tests can I run from this? First off, what tests can I run on this output? That's a little more advanced, MG. Like it helps with the understanding that lets you solve a lot of questions. Like this is test related, and it's a little more like having the knowledge to solve questions, like to figure out if something tries to do a conceptual question. What kind of, this is a straight tool. Now I'm asking a tools and techniques question. We want to analyze health shield GPA or number of pets. What kind of test could I run on this data? I've made a histogram. So what kind of test? This is a straight, like, this is a tools and techniques type question. Like, someone wants to look at the number of pets that UT students own. What kind of test could they run to look at the number of pets students own and test a value? A t-test. Exactly. The t-test is for the one quantitative variable, and so that's a straight, not a two-sample yet. The two-sample t-test, and great job, MG, right there. The two-sample t-test would be worded like, somebody wants to look at the number of pets people own and whether or not they're in the honors program. So now we would have people in the honors program and not in the honors program. So if you compare two means right here, those who are in the honors program, those who are not, I think the confusion for a lot of people arise when we say something like, we want to test if people own more than one pet. So if you want to test if people own more than one pet, people hear like the second mean, and then they think, oh, you're doing a two sample. Really? Okay, well, this is going to be fun. Didn't know it asked me for all of them. There's a trick and jump that you can do it on every single chart. Hold control while doing it. And so now I think a lot of people think, okay, wait, we have the hypothesized mean and the sample mean. Isn't that two means? But remember, when we talk about there being two means, and we're going to pets, when we talk about there being two means, we're saying two sample means are being tested. So let's think about how we analyze this. And so remember, we're doing just some advanced practice right here. This is a one sample t-test. So let's try to analyze these results and know the key concepts for analyzing tests, which pretty much is studying for the test. When you analyze a test, what are key things you should know when you're interpreting a test result? And I want to say this, one of the most common errors I see when I'm reading interpretations is it says interpret the test, and guess what people do? If I say interpret the test results, interpret the greater than test. So interpret the greater than test, and Leo's got some great answers right there. What do you think common error is? When it says interpret the greater than test, and usually you don't get maybe a half a point for doing this, what do you think a lot of people do instead? What do you think a lot of people do instead? I'm highlighting it to show you. One of the most common errors. If you're watching this right now and it says interpret the test, don't do this. A lot of people, well, I see a lot of stuff right there. Good work, pre-analysis. We don't say accept. Remember, don't say accept. Don't say accept. So one of the most common errors is instead of interpreting the test results, people go straight to the interval. They do the confidence interval instead. They start, I am this percent no. It's confidence interval stuff. No. We can do tests with confidence intervals, but we need to do the I reject or I do not reject portion of this. And so Leo's pointing out some really good stuff right here. There's things we need to know, which are concepts for us right here to interpret a test. Let's list out all the concepts and make sure people understand and know what these are. We need a null hypothesis. We need an alternative hypothesis. We need a p-value. We need a alpha level. And we need a decision. Okay. Can anyone explain to me any of these things I have on the screen here? Like, what is a null hypothesis? What is a p-value? Where are the p-values in this output? We'll start color coding stuff right here. So we should probably know I guess the tested value maybe. So the tested value is good too, or the null value. The null value is like, in the equations, you see it as like mu naught or p naught. Does anyone know what mu naught is in this right here? This is mu naught because I'm testing a mean. And Leo's pointing out the sidedness. Great job right there. Does anyone know what mu naught is in this equation? Like, where is mu naught in this output? It's the null mean. It is the null mean. It's the hypothesized, and there we could test if it's equal to 0, but I didn't test that right here. I tested if he was, and great job, MG, right there. I tested if he's equal to 1. So that is the hypothesized value right there. It's the value according to the null. Like, according to the null, and people are putting right there, and MG, that's excellent. The null hypothesis states that the true mean is equal to 0. So, or is equal to 1 in this instance. Exactly, is equal to 1 right there, exactly. And then I think you meant an equals right there. But the null states that the true mean that people own for pets is equal to 1. And just think of this when you say it. This person believes that UT students own on average what? Like, just talk to me like a normal person. Like, my friend believes this. Just talk to me like a normal person about this value. Don't say, the null hypothesis states. Write that on the test. They think people own one pet on average. Does that make sense? Like, my friend thinks people own one pet on average. I want to see if what? And let's go with this one right here. Here's where your alternative is. I want to see what? And look at the way this is right here. I want to see if there's evidence what? My friend thinks that people own one pet. That's their belief, starting out belief. So this is a starting belief. A starting belief we don't need evidence for. It's just what you just believe it. I think people own one pet. And then right there, great job, MG says the true mean is greater than one. I think you're wrong. I think people own on average more than one pet. Well, show me evidence of that. So the alternative is the evidence-based claim. Three different ones. It's just the way we test it. You can test to see if they own more than one pet, less than one pet, or if it's not one pet. They own or more than, exactly. Like, do people own on average one pet at UT, or do they own on average more than one pet? And without evidence, we're going to continue to believe that it's one. You need to try to change your friend's mind. And it's always based on the researcher's question for the sign of the alternative. Exactly. Great job, Laura, right there. Mu is the true mean. Like, I think, does that make sense when we say mu? Think about how the null is written. If you look at how the null is written out, it's written as the null states that the true mean of people's pet ownership is equal to 1. So you're saying, I think this is true. This is your hypothesized value right here. You're just, what can the hypothesized value be? It's not that you know that that is true. That's just what you believe in your head. The hypothesized value can be anything. And it will specify by wording the question, Eric. Good question right there, Eric. It can be anything. Your friend could believe people own 100 pets. And I'd say, I think people own less than 100 pets, and I think there's strong evidence for that. It can be any value you want for the hypothesized. And it's just what they believe that the truth is. Like, if I told you right now, how much money do you believe is in your wallet? Well, you don't have to say. But you would say, I believe right now, and if I had to guess, I believe right now there's like $12 in my wallet. I think I saw a bill that's bigger than 1, but I don't think it's that big. So if I said, I think right now the truth is that there's $12 in my wallet, maybe I'm wrong. Maybe I'm wrong. Maybe it's not $12. Maybe it's exactly $12 and I'm right. So we hold a belief in our head that this is the truth for the amount of pets people own. And now we're going to see if there's evidence that we're wrong. We're going to see if there's evidence for an alternative that the true mean of pet ownership is greater than. Now, we're not saying what it is. We just want to say, is there evidence? Fat Stacks, those $12, that $10 bill. I don't believe that. So the p-value is going to be the probability of what we saw given the null is true. And this means that it's conditional on the null. So you have to think, what is the null? And what is the most, if the null is true, I want you to look at this graphic, because this will kind of show it to you. If the null is true, what is the most likely amount of pets to see if people own one pet on average? If the null is true, and great job right there, Priya. If the null is true, what would be the most likely value to see in this distribution of values? If the null, well, we're testing to see things, but just think, if it's true that people own one pet on average, the most likely thing to see in our sample would be what? Just think of that. If it's true that people own one pet on average, the most likely thing to see would be one pet. What if we saw like 1.04? That wouldn't be that unlikely. What if we saw like 2 pets? That's off the charts. Now, we didn't see 2, we saw 1.2. Notice how this is your observed result. Does that make sense? Here's what you saw. Here's what you expected. Does what you saw, I know it's not that far away numerically, but does it look close to the center of this curve, yes or no? Does what you saw right here look close to the center of this curve? If I said put a line at the center of this curve, oh, but this is the average right here, Priya. This is, we saw in our sample an average of 1.23. It's not that, and remember, we're estimating what the true mean is, not what someone owns, not that people own one pet or own 1.23 pets. It's that the average, the true average amount of pet ownership is 1. So Leo. So this doesn't look that close to it, right? So this result looks what by random chance, which is the p-value. it looks kind of what? Like if I told you this is at the center of the curve, like this could just be at the center. You'd say this looks very what? Think of low probability. It looks very what by random chance. It looks unlikely, Barrett. And that's the idea of a low p-value is this result right here doesn't look likely given 1 is true. If 1 is true, we should land close to 1. And that kind of gets us down here to our alpha level. Alpha level is just an arbitrary point. And let me highlight a little bit better on this. That's the alternative. And there's the p-value that we are using. Once again, the researcher chooses this. Chosen by researcher, not data. You don't go by the data. We chose this to start. We said, let's see if you'll have more than one pet, and we collected data. Alpha level, assumed 0.05, but can be anything. And it's also type 1 error. So the alpha level is your type 1 error. Is there any way you could go over a question for that? We could probably, Kendall, and we've got the review thing up. We'll talk about that here in a second. Here's the review, and I'll point you to the video, and we could maybe do some examples with that and try to do some advanced. Thank you, Kendall, for asking. So the alpha level just tells us when we what the what. This is going to be very important for the next thing right here. The alpha level tells you when you what the what. So think of it as a limbo bar. The alpha level tells you when you what the what. So you put your limbo bar right here for your alpha, and whatever alpha is, if it's below alpha, and technically at or above is, let's say fail to. That's the way classical stats says it. So most commonly, and do not say, I want everyone to spam the bad word, which you should not put on your test. What is the bad word? Don't put this on your test. Please don't. My graders should be taken off for it. All graders should be taken off for it. You don't see this word right here. Oh, great job. Great job. Leah, shouts to there too. And thank you, Dem. We won't say accept. We don't accept. Prove, accept. Don't say those words. Don't say I accept the null or I accept the alternative. The words that go with this would be do not have evidence. Do not have sufficient evidence. And then the other one is do have evidence. That kind of gets us down to the decision right here. So if you notice, the decision is based on what? And don't say cause. Oof, don't say cause. Cause is a word that's going to be what? The decision that you make at the end is related to p-value below alpha, reject. P-value at or above alpha, fail to reject. And those sayings go with each one right there. So your p-value below alpha is reject. When the p-value is low, reject the null. When the p-value is high, just let it fly. So that's kind of a big review of testing right here and the important things we need to know. So let's look at this test result and see if you can do it. So I'll tell you how you do. Just I want you to take this. I'm going to put the question on the screen right here, and then we're going to do a few test practice questions right here. And that was a big concepts review. Interpret the test results at the 0.01 alpha level for the greater than test on owning pets or true pets, true pet ownership, true mean pet ownership. To 1 or is greater than 1. Yeah. The alternative being greater than 1, the null being, and you just need that right there. Scroll up a little bit. Yeah, sure. There you go. Try to interpret it right here. Interpret the test results at the 0.01 alpha level for the greater than test. So that's going to tell you the alternative. I'll highlight some stuff right here, and then I'm going to put the blank interpretation for the greater than test. So that's the thing you need to identify. There's your alpha level. There's the null value right there. Also, it's there in the output. So take a moment, try to think this through. I don't want to give the full answer away, but see what you can do with this. And you understand then how to do the testing right here. Interpret the test results at the 0.01 alpha level for the greater than test on the true mean pet ownership is equal to 1 or is greater than 1. Let's see what people say. Try interpreting it. I reject the null hypothesis that people own one pet at the 0.01 alpha level with a p-value of 0.003 to the p-value of 0.03. This means I do have evidence for my alternative that people own. MG right there, perfect. MG starting off strong right there, great work. I'm just going to copy paste that. That allows me to get a skeleton for us to use right here. Where's our skeleton at? Where are you at? There he is right there. Look at that. We got a skeleton. Woo! He's excited. Okay. And then we have to choose right here. Reject or fail to reject. And then that. The null hypothesis. And then we have to say our alpha level. I could just literally put, yeah, and then put alpha level. Due to the p-value. Put p-value right here. Definitely say it's a p-value. This means I do, so you do have evidence, and then you rejected, so we need to put do not. For my alternative hypothesis, there we go. For my alternative hypothesis, that. And then alternative hypothesis. Great work right there. And so this right here, let's bold it so people can see, and people are typing and practicing. Remember, if you reject the null, you do have evidence. This means I do not have evidence. Not have sufficient. Sufficient? Don't know how to spell it. Sufficient evidence. There we go. At your alpha level, state your alpha level. With your p-value, state your p-value. This means I do have evidence. MG, has it been, what do you think about writing these out? Now, I'm hoping this is the way to practice it right there. Great job, MG. We reject the null hypothesis that the 0.01 alpha level with a p-value of 0.003. That means I do have sufficient evidence to reject. And then make sure, Barrett, the last part to say you rejected the null, but you have evidence that the true mean pet ownership is greater than 1. So that's the only thing I would add to that, Barrett. Make sure to add in that last part that you have evidence that the true mean is greater than 1 for pet ownership. Leo say I reject the null hypothesis that the mean number. Make sure to say true or population, Leo. Make sure to say true or population, because that specifies like for like what we're examining the truth about this is. So make sure to include a true or population. Do not say sample in this. Do not say sample because this is proclamations of truth right here. This is not about the sample. And this interpretation for a one sample T, a one sample one-sided. The sidedness goes to, if people are wondering about sidedness, this is a two-sided and these are one-sided. So you could do a two-sided one sample T. Does that make sense? That p-value is the two-sided one sample T. We're still doing one sample T's here, but that is a one-sided one sample T. It goes to the shading on the curve. So the sidedness goes to what way we shade the curve. Like this is a two-sided, this is a one-sided, and I think all those p-values right there also came from a one sample T. The one sample T goes to how many means you are analyzing. So when we say one sample, that means we're analyzing one mean. I reject the null hypothesis that people own on average one pet at the alpha level of 0.05 with a p-value of 0.003. This means I do have evidence for the alternative that people own more than one pet. I do have evidence for my alternative hypothesis that that people own more than one pet. That people own, the true mean of pet ownership is greater than 1. As long as you put true mean in there once at least, that kind of clarifies. So we don't try to be too particular, but try to make sure to include things like true mean or population mean, stuff like that. Here, we'll do another one right here. Try to do this right here. We're going to grab this. Let's do another one. Nice work, MG. Great practice today. We're going to do another one here. Thank you for giving us that skeleton right there. We've got our skeleton to work with to practice, and let's go here and do the following and do a test on honors program. So I want you to think about this. Let's go to this one. No, this one doesn't do the sidedness. Let's go ahead to this one. Okay, so let's do a test right here on credit hours. Okay. So this would say interpret. We have evidence alternative. Doesn't mean that we it means we rejected the null. If we have evidence for the alternative, that means we rejected the null. If we have evidence for the alternative, here I'll highlight it. If we have evidence for the alternative, I do have evidence, means we rejected the null, and I fail to reject the null does not means I do not have evidence for the alternative. Does that make sense right here? These go together. So if you choose the route of, so if we have evidence for the alternative, doesn't that mean we have, it kind of means we have evidence against the null, but we'd say I reject the null. Like saying you have evidence against the null, we don't usually phrase it that way, so that is correct, Priya. But usually we just say I reject the null, I do have evidence for the alternative. Or we say I do not reject the null, which is fail to reject, I do not have evidence. I do prefer, it's just I'm worried, like, I would be fine with this. I do not reject the null. This means the same thing right here. Oh my gosh. This means the same thing. I reject or I do not reject, but I'm just worried with graders. A lot of times they go by the classical sense. So I just use this right here. I reject the null, or I fail to reject the null. That I fail to reject that the null hypothesis. I fail to reject, and then we could put that. I fail to reject the null hypothesis at the end and state the null hypothesis. Okay, let's take a look at this right here. This one right here is a result between people in the honors program and not in the honors program and the credit hours. So this is a more difficult one to interpret, but take a moment right here and let's do the does not. Try interpreting this. The does not equals alternative. So this is a 2-sample T. So this is a 2-sample T and it's two-sided. So this is a two-sided 2-sample T. The sidedness being decided by the does not equals alternative and the 2-sample being the two groups. So if you're wondering why it's 2 samples, we say 2-sample T because we have here a yes and a no group, and that's 2 samples. And if you're wondering why it's two-sided, two-sided goes to, trying to find a different color, the alternative we're using. So the two-sided means we shade, and I knew it would do that. Gotta find a better color. Trying to find one that's not being used currently on the screen. This one. The two-sided goes to the sidedness, and yeah, you can see that right there if I color it nice and through it. Goes to the sidedness of it. So try to write this out right here. So what would be the null hypothesis when we compare two means? The null always has the what. This is a thing we should know every time we do this. The null has the what. 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 And you can write it out. If you go here to the yes, no, and you write mu yes minus mu no, right there. The null has the equal sign. Great job, Eric, right there. The null has the equal sign. So what are we saying? Just think about what you're... Talk to me like I'm a person right now. Just don't talk to me like I'm a stats person. What does someone believe about people in the honors program and people in the not in the honors program? That between their credit hours, the true difference between them is that there's what? In their credit hours. Between the mean credit hours that they have. For our class, yes, Leo, but you can do other values. That value right there, which a statistician once told me, I didn't know you could test something other than 0. And it's like, well, yeah, of course we can. But you don't have to test 0. But for our class, yes. The test defaults to testing to 0. In reality, you can test any difference you want. You could also use the confidence roll to test differences too. That there really is no difference between the amount of credit hours people in the honors program, and there's no difference, right? Like if you look at it, the difference is equal to 0, that there is no difference. I reject, let me see right here. I reject that there is no difference in true means between honors program, kind of between those in the honors program and those not in the honors program, and the credits they take this semester with an alpha level of 0.05 and my p-value of 0.0016. This means I do have evidence for my alternative. This means I do have evidence for my alternative that they're what? And just think about this. There is a what? There is a true... There is a what? Because we're analyzing the difference right here between the two means. Notice how that we have difference. And then I would just add in between true difference in honors, true difference in credit hours on average. I reject the null hypothesis that there is no difference in credit hours between those in and out of the honors program at the 0.05 alpha level with a p-value of 0.0016. This means I do have evidence for there being, and I don't like the character limit either. I wish YouTube fixed that. You could do some rather long text, I'm sure, if they didn't have the 200 character limit. That this means I do have evidence. I think Leo basically finished it off for you there, right there. It means I do. There is a difference between those. Did Leo finish it off? Did you guys plan that out? It looks like Leo perfectly finished it for you. That's awesome. But yeah, did you plan that? But Barrett and Leo, that goes together right there. That is correct. So we do have evidence for a difference right here. And we estimate that difference to be what? What is your best estimate of the difference between people who, like the amount of credit hours? What is your best guess of what the difference is? Think of this from the output. We're just doing a bunch of questions. What's your best guess of the difference? What is your best guess of the difference? Great job right there, Barrett. 0.68, correct. That value right there, that is your best guess. That's the sample difference. That value is the sample difference. What is the margin of error of the interval down below? We're just rapid firing questions here today. Don't worry about being too exact. We can do exact calculations, but just tell me a guesstimate of the margin of error. When you can start seeing it and guesstimating it, then you can check your work. That's the goal of today, is to be like, can you just look at that and give me a guess of the margin of error? Be like, it's about this. It's about point what? Just it's about this. You don't have to be exact. We'll find it exactly here in a moment. It's about this. It's about this. Priya's doing it exactly. Great work, Priya. That looks to be exact. Great work. What do you think I would have said? I'd look at it and go, it's about this. It's about 0.4. Great job, Eric. You're seeing it, Eric. Great job. And Priya, great work too. That's the exact calculation. When you see that it's about 0.4, and how are you seeing that? I'd like for you to look at the following. If you're wondering how we got in our heads that it's about 0.4, I want you to start looking at it this way. Let's insert a shape right here to see how we're solving this. And I want you to look at the numbers now. Take a look at the numbers now and notice that the center of the interval is right here. And then here's the upper and the lower. Do you see it? Does it make more sense here to look at this? Now that's just giving you a guess of it, but you have 0.6 at the center, and then how much higher is 1? 0.4. How much lower is 0.2? 0.4. And then people are showing the work in the chat on how to find this right here, to find the exact, and great work right there. Is that making sense? Eric, you have the full, and you have the full length, then divide by 2, Eric. So this is just a good way to check your knowledge, to say, okay, if the center of the interval is about at 0.6, and the lower of the interval is about at 0.2, and the upper of the interval is about at 1.0, then the margin of error is plus or minus 0.4. Now, I wouldn't do this completely this way, because we need to take more decimals on this, but you can see you should get numbers close to this. And then Priya, great work right there, taking the center minus the lower, which is a great way to solve it too. No worries, Barrett. There's a lot going on, Barrett. Hey, Barrett, you got this. Don't worry. Just take a breather. I'm doing different ways of teaching today. I'm being a little more advanced, I would say. Not saying like, but like I'm doing it a different way. Like, like when you work on a muscle, if you just do curls like 1,000 times one way, your brain doesn't, you just get stuck in that mode. I'm throwing curveballs at people today and seeing if we can do it different ways to kind of, and it's a lot of info. So Barrett, shout out to you. Shout out, Barrett. We'll give you a Wacky Wednesdays. You earned a Wacky Wednesdays. We're not doing points today. We're just doing Wacky Wednesdays. Wait, is it Wednesday? No, it's Tuesday. It's 20 Point Tuesdays. Okay. Well, we did 2 in test interpretation. Let's do another test interpretation. Thank you, Priya, there for that positivity. We're always here to encourage each other. Let's do another test interpretation. Brian has switched back to doing what kind of test right here? This is like a tools and techniques wave. I want to analyze salary, and I don't want to test if people think they'll get a salary of $1. Can you write a blank interpretation for this, please? We did it right here. I reject or fail to wait. Oh my gosh. Sorry, that was wrong right there. Right there, Priya, does that make sense? There it is right here. Sorry, I had it wrong. So I reject or fail to reject the null at the something alpha level. We got to put in the alpha level due to the p-value, whatever the p-value is. This means I and then you do or do not have evidence or sufficient evidence for my alternative hypothesis that, and then state your alternative. Yeah. You can, Barrett, email me, fill out the form, email me. You want to take it earlier tomorrow morning? Yeah, we can do that. Barrett, let me know. You can take it earlier. We don't push back the exam, but we do allow it to be taken earlier. So let's get you in there. Yeah, you can take it earlier tomorrow morning, Barrett. I'm glad we can give you that bit of positivity. If you want to take it earlier tomorrow morning, so email me, Barrett, fill out the form. I'll be checking the form later to make sure we've got everyone entered in, but I think I've entered in everyone who's taking it earlier. Awesome. You got it, Barrett. You got it. Yeah, this wisdom. Sorry, man. I got my wisdom teeth out at 30. It wasn't fun. But you got it, Barrett. You're going to do great. So, rooting for you. Just switched it and took it today. No, but if you want to take it today, you just email me and we'll get that set up for you too. I'll check that after I do the stream here to see if anyone filled out the form. Earlier the better. That way, if you fill it out like today and want to take it today, I need to go check that. I've been keeping up with who's been asking. Okay, so there's our blank interpretations. So who knows what kind of test we are doing if we're over here looking at salary? And I just want you to think through, if someone told you, I think UT students expect to make $1 when they graduate. I just want you to, what you would say to them. It's a t-test, right? It's one quantitative variable. It's a t-test. I just want you in your head to not use statistics. And your friend says, I think people expect to make $1 from UT when they graduate. You'd be like, that's ridiculous. You can't even see. There's what we saw in the sample. So here's what we saw in our sample. And here's if the null is true, which it might look like that's at 0, but it's actually at $1. It's just that it's so close to 0. So you can see with the other graphics, like it's at $1 if it's not super duper far away and it zooms out. So it looks like it's at 0. Actually, I can kind of tell. Yeah, I can't. It looks like it's at 0. But it's actually at 1. Even though it looks like it's at 0, it's actually at 1. But here's what we saw. What we saw in our sample was virtually what, given the null is true. What we saw in our sample, which is the red line, which is what we see right here, $61,000, is virtually what, given the null is true. And it probably just should say 0 for this if I hover over it. What we saw in our sample is virtually what. If the null is true, and it's really true that students expect to make $1, it's virtually impossible. It's like super... You would just laugh at your friend and be like, you think students expect to make $1 annual salary when they graduate? And they're like, yeah. And great job, Zoe, right there. It's basically just not like, sure. It's like at this point, it's the probability of winning the lottery like every day for a year. Like what we saw is virtually impossible, like literally virtually impossible. Literally. Throw a few literallys on there. It helps. So that's what we're seeing right here with this p-value telling us that it's not likely. It's much more likely that the true mean is greater than it. We would not have evidence that it's less than $1. We don't have evidence it's less than $1. Let's test another value here, and I'd like for you to see this. You can already tell me, and I want you to take a guess. If your friend thought that the average student expected to make $60,000, we're doing some concepts here while we do this, and you said, I wonder if that's not true. Would you reject or not reject? Now, don't do the test this way, but this is what you can do. I want you to look. I'm about to test the value of $60,000 as a hypothesized value. So I want you to think, if Brian tests $60,000, do you think we should reject that value or not reject that value? And you can already kind of do the test, but don't do the test results this way when you interpret them. But I'm just showing you a concept right here, which then will know the answer to the p-value. And I haven't done this output before doing it, but I can guess the p-value for you. We're going to not... How did you know that, Zoe? How did you know that? How are you doing that? I'm guessing a p-value of this. There's my p-value. Why are people saying not reject at the 0.05 alpha level for not equals? It falls within the interval. Take a look right here and don't interpret the test results this way. This is a concept we can use when looking at tests. It's within the interval. So the interval right here contains 60,000, which means we would not reject it at a 0.05 alpha level on a two-tailed test. So my guess of the p-value is 0.0507. I promise I didn't do this beforehand. Dang it, it's 0.0502. But I was within 5/10,000ths of the p-value. That was a guess of the p-value. I wish I had guessed 0.0502. I knew it would be clear host right there. Eric, so glad. You're welcome anytime. Good to see you and glad to helping you out right there. That's anytime right here. You got it. Watch the rest later. Oh man, we'll throw you here a randomness. You know some randomness if you've been here. A little randomness for you right there. A little randomness, a little know your little hacker man. We'll do hacker man too. Little hacker man right there. I'll click all the buttons today. I was trying to fix some stuff yesterday, so awesome. Well, thank you, Eric. That's great. You're welcome. So when you look at this test result right here, now we're going to interpret the two-sided alternative. This is a what t with the does not equals test. Now be careful. This is where we're kind of getting to some, understandings of this. This is a what t with the what alternative. We're going to interpret these test results right here. It's a two-sided correct. Bingo. Great job. Excellent work right there. It's the two-sided. It's two-sided because we mentioned as we were interpreting this, we were going to see if it's not equal to. That's also the one that confidence intervals relate to. Confidence intervals directly relate. That's not going to be part of our interpretation down there. But the confidence interval containing 60,000 directly relates to the two-sided alternative. And thus, with the hypothesized value being contained within the confidence interval, we did not reject it. This hypothesized value here was contained within it. It's not going to be part of our interpretation, but it did allow us to know what the test would be before we ran it. So you can just look at stuff and be like, oh, well, I guess we wouldn't reject that. Like someone might not even run this test. But so how would you interpret this? So take a moment right here in the chat. This is like your test question now where it says like interpret this test result for the does not equals. What would you say right here? We're testing the true mean expected started salary of UT students. The null hypothesis would be written out the following way. I'll write it for you in words right here. The null hypothesis states the true mean is equal to 60,000. We'll put 60K right there. The alternative, we'll do the zeros. So what would the null be? Or what would the whole thing be? Okay. So we got the null, the true mean is equal to 60,000. The alternative being the true mean is not equal to 60,000. What would it be? And I think we're going to do question 4 after this. So great work. We'll try to spin it into some new stuff. So what would this be? Try to interpret these test results right here. So would you reject? And if you don't see an alpha 0.05. There was no alpha stated, but we have to assume alpha 0.05. Take a moment, see if you can do this. And this is like knowing the concepts then that alpha is when we reject the null. P-value is currently above alpha. So we have to choose a certain pathway here. We'll see what people say. But just see what you get right there. Probably do question 4 and take a break. What do you do? So the first thing to think about is, are we going to reject or fail to reject the null? Remember, don't say those bad except words in here. So we're going to fail to reject the null. And why do I know that? Because the p-value, great job there, Parker, excellent work. We're going to fail to reject the null. I fail to reject the true min salaries being equal to 60,000 at the alpha level of 0.05 and with my p-value with a p-value of, do we say end I would probably say like with my p-value of this, like it's why you fail to reject. This means I do not have evidence from alternative that's true min salaries different from, exactly. Great job there, Leo. I would just a little bit of wording right there. At the 0.05 alpha level with my p-value of this, because you could say because of my p-value of this, like that works right there. I failed to reject the null hypothesis that the true mean expected starting stars UT students is 69 at the alpha level 0.05 due to the p-value of 0.0502. This means I do not have sufficient evidence. Great job, Barrett, right there. Barrett, you're getting it down. You're getting some great practice. I failed to reject the null at the 0.05. Probably say alpha level, Zoe. Make sure to say alpha level. Like specify. Probably, I would want the grader to give it to you right there, but we're going to make everything perfect. At the 0.05 alpha level due to the p-value of 0.052, which means I do not have sufficient evidence, I'd probably throw in there for my alternative hypothesis that the true mean is not 6,000. Great work right there, Zoe. And Allison says, I failed to reject the null. I failed to reject that the starting annual salary is $60,000 at the alpha level of 0.05 due to the p-value of 0.052. This means I do not have an alternative that the starting annual salary is different than 60,000. What type of test was used? Let's do it. Great job, Curio, right there. You get a puppet shark. What kind of test was used? We're doing memes today. What kind of test was you here? Remember, everyone, this is a what test. So we are testing and look to the variable. It was a two-sided. Now that goes to the alternative. And exactly, it's a two-sided and one sample T. Two-sided, and great job right there, Zoe and Priya. It's a two-sided one sample T. And the way to know if it's one sample or two sample is one or two sample means how many what's we have. So fill in this blank. One or two sample means how many, you could say means, but if you think about it this way, it means how many what? Because here's a two sample T. One or two sample means how many what's we have. Here's the two sample T's. It is how many means. We have a sample mean for no and a sample mean for yes. So here we have, it is two variables. It's like two groups, right? Does that make sense right here with the two groups? Like you're testing people in the honors program versus people not in the honors program. And anytime we do a two sample T, we'll always be analyzing the what between these two groups. Anytime we do a two sample T, you'll always be analyzing the what. And that's a good way to know it right there. When you do a two sample T between the two groups, you'll be analyzing their difference. So that's a good way to know the two sample versus the one sample. And anytime this is when you know it's a T, we know these are T. All of these outputs on the screen are T outputs because the T analyzes a what variable. All of these output on the screen right now are T outputs, like annual salary and all this stuff over here. These are all T outputs because the Y variable is what? The Y variable is what? This is all because we're analyzing GPA. It's a quantitative Y. So the T-test is for a quantitative Y. And then the one, there's a one sample, is when we have one mean, like what are people's starting annual salaries? Or we could do a two sample where we say, what is the difference between people who are in the honors program and not in the honors program and what they expect to make? Is there evidence? Good quick question right here. Is there evidence that people in the honors program expect to make more money on average than people not in the honors program? Just a quick question. Is there evidence that people in the honors program expect to make more money than those not in the honors program? This is a two sample now. We're doing rapid fire questions today. Is there evidence that people in the honors program expect to make more money than those not in the honors program? So I'm asking you for a one-sided alternative right here. The null hypothesis would be written out that between the people in the honors program, yes, and in the honors program, no, there is no difference. The difference is zero. The alternative would be that between the two groups, we're talking about the truth right here, that the difference is greater than zero. And take a look. Since we're using the greater than, it means we're right here. So, and so how would you interpret this? Just another rapid fire question. This is a two sample T with a one-sided alternative. Reason that it's two sample goes to the two samples. The reason that it's one-sided goes to the greater than alternative here for the sidedness of the test. So that's a two sample. Two groups are being tested for their difference. And then we have a one-sided alternative. So how would you interpret this? Take a moment right here. Curio, great to see you as always. Try to interpret this result for a two sample, one-sided alternative to see if students in the honors program, which I didn't expect the p-values to be that close, but we're analyzing that one. It's really interesting how it just barely, wow, barely includes zero. But we're not analyzing the does not equals alternative. Barely. We're seeing if there's evidence that they think they'll make more, which is a one-sided. The researcher asked the questions, do honors students think they'll make more than, on average, than the non-honors students? Is there evidence? So take a moment right here. We're doing a lot of practice. We just need to get practice saying I blank the null, or I don't blank the null, or I fail to reject. And then state your null hypothesis. Everything up there in bold is what you need to fill in. And so try doing that. Try writing this out. Try practicing it. The more you're writing it down, the more you're saying it, the more you're practicing it. Because hearing me saying it is one thing, and then practicing it's another thing. I promise you, everyone here who's been writing it has been writing it a few times, and they're getting great at it. So just take a moment yourself and try writing it out up here if you're watching this. Anyways, here we go. I reject the null hypothesis that the salary of someone in or not in the honors program is the same. Throw the true difference. Pretty much Priya is the same with an alpha level of 0.05 and a p-value of 0.025. Yeah, and then probably say do the p-value of this like at the blank alpha level. Usually you say at the blank alpha level. Don't worry, that'd be fine right there. The bigger thing would be that I reject the null hypothesis that the true difference between the expected starting salary of those in the honors program and those not in the honors program is 0. That's my only change right there. Let me see what I wrote. I reject that the starting salary of those in the honors program is not different than those, and then probably say the true mean. Did I say true mean? I'm hoping I said it. I reject, if you notice what the null is, I reject the null hypothesis that the true difference between the mean of those in the honors program and the mean of those not in the honors program is equal to 0 on what they expect for their starting salaries. This is probably one of the hardest ones to interpret again, but just try reading it here, that the true mean of those in the honors program minus the true mean of those not in the honors program, the difference right here. This means there is evidence that someone in the honors program expects to make more money on average. There is evidence that those in the honors program expect to make more money on average. And then make sure to say on average. It's not that an individual would be like on average, that students. So you could say there is evidence that students, but you don't want to say like an individual student because that is one person, not the average. For my alternatives, that students, exactly. This was a harder one right here. This is like an advanced one right here, and try writing out these out as you do them. Okay, so let's do one of the test questions. On average, great job right there, Priya. We'll head back here to the main screen. Okay, someone was asking about the review questions, and so let's do the review question 3. We haven't listened to any music today. I think actually I've got the music button off. I need some lunch here in a little bit. How's everyone doing today, though? I try to ask that every day. I try to remember to say, how are you doing? How's your day going? How's your week going? We're almost done. I'll be teaching Miniterm here in just a little bit. Just playing the review in the background. Miniterm coming up soon. Can we go over errors? Yeah, let's do errors right after this. You bet, Priya. We'll do a speed run of, or not a speed run, but we'll do some error review. We'll do, and thank you, Priya, you asked that earlier, so let me put that on the list. So we'll figure out what this is, then we'll do error review, reviewing errors. Okay. Good day. I ate an avocado. It was good. Nice. Howdy. What's up, Nico? Oh, Nico. Former student, right? Nico, good to see you as always. Future MSBA in the chat. Are you future MSBAs? Are you in a future MSBA? Did you get into the MSBA program? We might have future MSBA students. Nico from, I'm trying to think which semester. I'm trying to think, Nico, were you winter mini-term? No. Were you which semester, Nico, if you want to say? We'll head over to the main screen. We're going to start up review question number 4, I think. We are finishing. We have our test tomorrow night. Can you go over a review of power and errors? You bet. We're doing errors after this. You bet, Barrett. Mine is done. That's awesome, Curio. That's great. We started a little bit late because we did a thing called winter mini-term. And so we started a tiny bit late. So we said, you know what? We're gonna relax and do some winter mini-term. And I taught it. Congratulations, Nico. Congratulations right there. I'm trying to think of what button to press. We'll give you a Smash Bros effect. We're doing effects today. I don't know what face to make when I freeze. It's supposed to move me across the screen, but something broke on Streamlabs or the Stream Effects. You can use the 84. You can use the TI-84. You're honored. Well, I'm honored. Great work, Nico. That is awesome. Might need to pull up the actual test for this. Okay, so let's talk over some output right here. Let's talk over the one sample T output. Here we go. Let's do it. Okay, so I want to point this out. We have these videos right here. You're going to see it again in the chat. But review 3, Mubot's going to help us out right here with review 3. So if you're looking for any of the test question videos, they can all be found right here with tons of test question videos on review 3. That page Mubot just linked. Just click that page and boop, you'll go over here to review 3. You'll see the main stuff that you probably want to go to right there, but then test question videos, speed run videos with long hair Brian with the big intro.
Epic. 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 Epic Stat Tool 1 speedruns of statistics. Brian Stevens versus Chapter 14, confidence intervals for the mean and standard sigmoid distributions.
I forgot that one. I couldn't say the full thing, and I don't know why I didn't. Usually it says the chapter review. This is a great set of videos down here, too, where I go over each test. Like if you want more in-depth on the 2-sample t-test, I walk through, go through all the interpretation and show you just kind of each bit of the output or what's in the equation, do an example problem right here and go through the 4 steps to hypothesis test, writing the equations, going through each part with rejecting or failing to reject at the end of the test, showing the p-value and all this good stuff. Yeah, in the conditions video, Leo asked about that. Leo asked about the conditions. So you get to see all the conditions right here. And I go through and talk about the conditions right there with nearly normal, expected cell count. I probably would not use my handwriting. That is me literally trying to write the best handwriting I can possibly do. But talking about the t-test, the 2-sample t-test, the 1 proportion, the chi-squared right there, and the different conditions, and you can see them visualized. That's why I always say random and 10%, success failure, nearly normal, expected cell count. What are we about to go over right now? We're going to do errors next. Someone asked about a test question. So we're going to go ahead and they said question 4, then we're going to do errors right after this. Here it is right here. Here is question 4. And remember these videos, I just want to point out that these videos are out there, but we're going to talk about this really quickly right here and see if we can solve it. So this is a good review right here if you've already done it. Now take a look at this. What do we have right here in notation? The first thing I would do, it can be checked by large enough n, that is correct. The first thing I would do is I would start marking all of this notation if I saw this on the test, because it's not about solving one question, it's knowing what every bit of this notation is, and then you can solve tons of questions. So what is the mean in this output? What is the mean in that output right there? We want to know all these values, every one of these values right here, which will lead to solving everything. What is the mean in that output right there, like notation-wise? It is 24.03, exactly, Allison. And then, but remember, it's shape of it too, Leo, on the large enough n. The more skewed it is, the larger it needs to be. And so Allison's right, it's 24.03, and that is y bar. That is the sample mean. Standard deviation is known as what in notation? Standard deviation is known as what in notation? That's an easier one. Standard deviation. Standard deviation. It's S. Great job, Allison, right there. Standard deviation is S, and that's sample standard deviation. Sigma is population, but we don't know the truth. We only know what we saw in a sample. Now, you could take the standard deviation. Can anyone solve what the standard deviation is divided by the square root of n? Before I hit enter, I'm going to tell you that this value is going to be 0.60535. Oh, really? Did it not carry enough? Did I type it in wrong? What? 33 square root. There it is right there. Does Jump do it a little bit differently? I'm going to be mad right here. I don't think Jump... Oh, wait, there it is. I made a typo or something. I don't even know what I did wrong. What did I just solve for by doing the standard deviation over the square root of n? What am I solving for by doing the standard deviation over the square root of n, which I'm apparently not doing anymore? What did I solve for by doing the standard deviation over the square root of n? Oh, I'm taking that. The standard deviation over the square root of n is what? The standard deviation standard error, exactly. The standard deviation over the square root of n is the standard error. Jump likes to say capital N right here. We say lowercase, that's sample size. And so we get all of this stuff right here. Other things that are removed from this. What is the degrees of freedom right here? What are the degrees of freedom going to be? What would the degrees of freedom be? So what are the degrees? Oh, we didn't mark this part of the video. We've been doing this for about 2 minutes. So I think people are answering that. We're going to take a guess at the timestamp. T-test review. Output review. The degrees of freedom here are n-1. Everyone's getting it in chat. Great job. This is the 1 sample t, n-1 degrees of freedom. So we know formulaically the degrees of freedom are n-1 for the 1 sample t. Key thing right there, 1 sample t. So the degrees of freedom are 32. Now the actual estimate is the sample mean. So the 24.03 is the estimate. Remember, we estimate the truth from the mean. So even though that's blanked out there from the output, the actual estimate is the sample mean. Standard deviation is the standard deviation of 3.48, we'll round to. So what you could do right here, and I think the test has you do a little bit lower, it's got the p-values blanked out. But from this, what do you think we could solve for? What do you think we currently have on the screen that we could solve out? Oh, and I didn't mark that. This is the hypothesized mean right there. That is the hypothesized mean. What do you think we could solve out for right here? We could solve out for, and there we go. We could solve out for the t-statistic, the test stat. And so with this right here, there's a lot of theory you could use to solve this out. The observed minus expected exactly, or technically observed minus expected, Leo. We observe a sample mean of this. We minus the expected, which is the hypothesized value, over the standardizing factor, which is the standard error. And so when you do this, what t-statistic do you get? Who can tell me? I've got an estimate in my head, but just try to solve it for yourself. Solve the t-statistic. It should be a little greater than 3, but try to solve that. So the 3.3, nice job right there, Priya. Okay, so the t-statistic, 24.03 minus 22, that's the difference, divided by 06, 05, there it is right there. Oh my gosh, that's why you do it in your head, because you do something crazy. And then you're like, what have I done? Oh my gosh. There we go. 3.35 exactly, and then just some extra decimals. Do you know any chance where I could find the recording from Alyssa's review? Leo or someone else might have it. She's got it posted. I don't know exactly. She posted like to Canvas and stuff. I think I saw an announcement with it, but good question, Veronica, right there. So there's the t-statistic. So if you draw your t-curve, I want you to notice something about this. Your test statistic is 3.35. Thank you, Leo, right there. You get a puppet shark for that, Leo. A mini puppet shark. So your test statistic of 3.35 is way over here. 0, 1, 2, 3. You're way off the curve. So tell me, the greater than alternative is probably close to what? The greater than alternative, which is this one right here, is probably close to what? Just give me a guess of it. The greater than alternative is probably close to what? The greater than alternative, which I've shaded in for you, is probably close to 0. The does not equals alternative is probably what of 0? The does not equals alternative is probably what of 0? Also basically 0 because it's 2 times 0. The less than alternative is basically the whole curve, because if you did the less than, you would shade the full curve right here going below this. If you go below your line, it's basically, and it has to add up to 1, so it's probably close to 1. So it's probably close to 1 right here. I'm trying to remember what we tested for this. So if we look down here, it wants this one right here. Based on this output, what is a possible p-value for the next p-value right here? Now, if you look at this, we estimated about 0, so this is going to be the right answer here, E. And the reason we know this for certain also, I wish we hadn't put this right here. The output is still showing offers no clue. That's kind of like, some people did answer that it offers no clue, but it does offer clues. What do you also know, and this is a really quick solve on this, what do you know about the value of 22 by looking at this? What do you know about the value of 22 by looking at this right here? 22, according to the interval, would be what? 22 would be whatted according to the interval, which is a much quicker solve for this than doing what we did here. 22 would be what? Is it in the interval? Is it in the interval? You might have had a 22 would not be in the interval. Does that make sense? 22 is not in that interval. So since 22 is not in the interval, we can reject it, right? And if we can reject it, the p-value has to be what? If we can reject 22, it means the p-value for the two-sided has to be less than 0.05, which means that we should be able to reject it on the greater than test, which is going to have an even lower p-value. This was a tough one right here. That is a pretty tough conceptual question, but also knowing the output's very important too, like knowing what those values are, how to find them, and that you would say we can reject that, which means it's not likely. And did we do? Yeah, we did the does not equals. So it can be rejected at the 0.05 level. So the only one, exactly, Kendall, right there. Does that make sense, Kendall? Like the only plausible p-value is that since 22 is not in the interval, it would have to be rejected. And so does that make sense? Like we know for 100% certain is less than 0.05. It's pretty close to 0 by using this metric right here. So if you go by this metric and draw it out, like this is an extended solve of the question. I like to do like a different solve if we do it. We have good reason to believe that the p-value of the two-sided is basically 0, close to. So the one that is most coherent with this answer would be that 0.0051. But additionally, we know we can reject it at the 0.05 level due to this evidence right here. And that's got it. Yeah, that's a really good solve. And once again, we did a more advanced solve on it, but do realize you could just use the confidence interval right there to deduce the p-value. That's one of our toughest questions I think we've written in a while because it's very small output, not an interval, and then we can reject it. Exactly. If it's in the interval, you would not reject it at the 0.05 level. If it's, so what if it gave a value, so what if we hypothesized this? I'm not loving this question, but what if it did a hypothesized value? What if the hypothesized value, hypothetically speaking, the question changes? And I want you to see this. I'm just going to show you. This is a theory question. I wouldn't love it, but it could be another theory question. What if we had a hypothesized value instead of 22? The hypothesized value was 24.030303. What would be the right answer down there on the bottom? And then question 2. We can do that here in a little bit, Luke. You bet. We're going to do some errors next. What would be the p-value if we did this? So the way the curve works is the null value. So that equals mu naught. The null value goes at the center. So you'd put the null value here at the center, which is that value. And then you would put where you landed. You landed at that value. And then you would shade both sides. So what is the p-value? P-value is what? It's 1. Because we saw exactly what we expected to see according to the null. And that's what the p-value of 1 means is I saw, like, I thought it was 24.030303, and then in my sample, I saw that value. Now, it's kind of weird you thought it'd be that exact value, but you thought it'd be 24.03030303, and then you saw 24.030303. You saw the what thing if the null is true. In your sample, you're welcome, Kendall. In your sample, if the null is true, you saw the what thing. In your sample, you saw the what thing if the null is true. You saw the what thing, there's a word, like something likely. What you saw was the what thing given the null is true. Well, you thought 24.0303 is true, and then you took a sample and you saw that. So if the null is true, you saw the what thing, something likely thing. And that's what the p-value of 1 means. You thought 24.0303 was true, and then in your sample, the p-value is 1 because you saw the most likely thing, and most likely. Does that make sense, Priya? I think Leo said, so what you saw in your sample was the most likely thing. This is a different problem I made up right here, but you saw exactly what you expected to see. So you wouldn't reject the null because you'd be like, well, I thought it was 24.03, then I saw 24.03, so it's kind of what I expected to see. I have no evidence to reject the null. So, and just to briefly kind of do another example of that, if you look at some of the problems we've been doing over here, I just want you to think, just take a guess. What do you think, how many hours a week do you think students work? This is how statistical tests actually work. How many hours a week do you think students work? Now, don't find the answer to this. How you know it's, and then this might help Priya right here. We'll do an example with this. What do you guess is the amount of hours students work a week? Like on average, I think students work this. Doesn't matter, any hypothesized value. This is your mu naught. So how many hours do you think students work a week? It can be anything. This is just your mu naught. So what is your mu naught? Don't say 8 to 10. Don't give me an interval. Don't give me an interval. Priya says 30. So Priya says 30. Riona says 12. So we're going to go, Priya, you think they work 30 hours a week. Now I'm going to go out and talk to, I think, 806 students. So you think it's 30, right? Does that make sense, Priya? You think it's 30. And so now we're going to see if there's evidence that you're wrong. Does that make sense? This is just what you believe. You think it's true that students work on average 30 hours a week. We're going to see if there's evidence you're wrong. But Priya, if I go out and talk to students and 30 is true, what do you think my sample mean will be close to? If 30 is true, if I go out and talk to students, my sample mean should be close to what? If 30 is true, so assuming 30 is true, we should probably see something close to 30. So when you see this, and great job, Leo, right there, when you see this distribution, I want you to see how it looks. If I test the value of 30, what goes at the center of the curve for the most likely thing? At the very center of this curve is what value? At the very center of that curve is what value? 30. Now, what did you observe? Sorry for the lag right there. You observed students working how many hours on average? You can round it. You observed students working how many hours on average? And don't worry that you're wrong. The concept is here what matters. You thought, I expect students to work about 30 hours on average. But you observed in your sample, they worked about 8 hours, 7.9, right? So you observed that. So tell me, and just think, maybe don't use stats even. With this right here, Priya, have I changed your mind? Just think about what stats means. Have I changed your mind right here? You're like, yeah, it looks like, and don't worry, this was the goal of it. You're like, I don't think they work 30 hours. Because it looks like from the sample, what we saw in the sample would not be likely given they work 30 hours. And Leo and Rihanna, great job right there. If we tested 12 hours, Leo, have I convinced you? And now look, it is closer. Leo, have I convinced you to give up your belief of 12 hours? Leo, are you like, I think they work about 12 hours on average? And Leo's seeing with that. So Leo, have I convinced you to drop your belief of 12 hours? To be like, yeah, I don't think they work 12 hours on average. Like the average student works 12 hours. You'd say, I don't believe that anymore because what you saw is not likely. Now, what if someone said, now this is the ridiculousness of it. What if someone said, I think some student in the class said to me, and this goes to our previous example, Priya, they said, I think students work this many hours. And I want you to notice the number I'm putting in. And I don't know why you would have said this, but if someone said, I think students work, make sure I'm getting it right, that many hours, what did they then? This is what they hypothesized. I asked them, how many hours do you think students work? They said, I think 7.9075682 hours on average. And then when we went out and took a sample, we saw exactly what they said we would see. What we saw was the most likely thing. And this is what we were graphing out a second ago, Priya. So now that red line is exactly on the null. And the probability of this or something greater or less than it is 100%. Because they said, I think this is what we'll see. And then we saw exactly that. So that's the most likely thing to see. Now, you don't do tests that way. You don't make the null hypothesis what you see. You question, what do I think I will see? And so is this making sense now, Priya, why the p-values here is 1? Because they saw exactly what they expected to see. They saw the most likely p-value of 1, most likely thing to see. If you think about, Leo said, what if someone said 7.5 hours? If 7.5 hours is true, is what we saw in our sample likely or not likely? Remember, we saw something higher. If you can't see, there's a red line right there. Is what we saw in our sample possible? Given 7 point, it's likely, right? So what I see, could someone share the link as to where the formula sheet? It's on review 3. There you go, L right there. Review 3 in the chat. Mubot will put it there for you. And Leo helping out right there. Awesome. Thank you, Leo. Both Leo and Mubot have the link in the chat. So there's review 3 right there with the formula sheet on it. But does this make sense right here? What we saw was pretty possible given the null is true. There's a red line right there. So I would not reject the null. If someone said, I think students work on average 7.5 hours, I'd say, okay, that's believable. It's believable. Okay, so let's do some errors right here. Oops. Time for some errors. Let's do it. Reviewing errors. How many people we got watching right now? A lot of review today. Head over to the main screen. Time for errors. Reviewing errors in power. We'll probably take a break. Go on some Pokemon walk. Reviewing errors. 16. I'll take it. Maybe I should have reviewed later at night. I don't know. Got a lot of videos out right now. Okay. When it comes to reviewing errors, here's the number one thing to know. Someone asked in the Discord, and please ask all the questions. They asked, how can I remember type 1 and type 2 error? Who knows this trick right here? I know, right? I love it. Good practice. You'll be ready. So always practice by doing it that way. In a type 1, great job, Allison, right there. In a type 1, the null is true. And if the null is true, what's going to be the error? In a type 1, the null is true. This is the 1. This is the true. And then it's going to be, then Luke right there. There we go. Luke's doing right there. You might be. I could tell you what percent you are in the class if you wanted. I can release that info. Can't tell you like other people's, but if you say, where was I in the class, I could look and tell you were this rank in the class if you really want. Exactly. Pre right there says, in a type 1, the null is true and we reject it. In a type 2, the null is false and we what? There's the second F of the type 2. So type 1, null is true and we reject it. That's the error because we don't want to reject the true null. Type 2, null is false and we fail to reject it. There's the two F's of the type 2. The two F's of the type 2. AL is a word. I don't want that error underneath. Okay. So in a type 1, the null is true and we reject it. In a type 2, the null is false and we fail to reject it. I know, and Hannah made that up a while ago. Really the best way to memorize it, just memorizing a type 1, the null is true and we reject it. Type 2, the null is false and we fail to reject it. And you only talk about the null. Don't talk about the alternative. Now, this does give implications for the alternative, but a key thing to know when you do this is to only talk about the null hypothesis. This second part right here is the error in judgment. So if the null is true, we should what it. Now, I'm asking this in a different way than what is written, but if the null is true, we should what it. If the null is true, we should what it. If the null is true, we should what it. If the null is true, we should do this. The last part's the error in judgment. And this is more just concepts on it. We should fail to reject it, right? If the null is true, you shouldn't be rejecting it. If the null is true, you should not reject it. And then the error in judgment is if the null is true, rejecting it is the error. Just like if the null is false, what should you do to the null? If the null is not true, you should what it? The null being false, right here, if the null is false, you should do this. Now, we're not saying what the errors are here. If the null is false, you should do this. You should reject it. You're saying this is false. I reject it. You should do that, but you make an error in judgment. So kind of one of the most common questions I get is, well, why would we make errors? It's I agree. Let's not make errors, but we're human, right? So we're going to make errors in judgment. And so that's what statistics looks at here is when someone makes a wrong decision on a test. And I think my classic ways of doing this, here, we'll try to think of another example. We came up with one, the friend picking you up, which I thought was really cool. We got tree example, human error always occurs exactly. Let's say right this. So I like to talk about my sister. She does real estate. Not market to someone. I want us to think about this. So my sister Emily has this really cool flyer, and this really cool flyer, she's trying to sell house right here, and she's thinking, should I send this flyer to someone? And this is like a super cool house flyer, and it's got all this cool info. There's a house on the flyer. It's super duper cool. And there it is right there. Got a little door on the house, and it's like all this. This costs her $10 to make. $10 to make, okay? Now, she would need what to send this to, because she's not just going to send this to everyone here in Knoxville. So, oh, thank you, Leo. I appreciate that. That gets a puppet shark. She's not going to send this here to everybody. She would need what? She would need what to send it to someone? She would need what to say, I got this flyer. Before I send it to anyone, I'm going to need what to send it to someone? What would she need? evidence, right? She needs to be like, there's good reason to send this to someone, right? So when you think about what a type 1 and type error are, let's do what is a type 1 error in this context. So I'm going to put some stuff up here. What is a type 1 error in this context? So don't answer quite yet. Neither address to send to them. That's true also. So don't answer in the chat yet. What is the type 1 error? So it's either going to be markets to someone who is not interested, markets to someone with no interest, or doesn't market when should have. So losing a sale. Losing a sale. Failing, not... losing a sale to someone would have bought. Losing a sale to someone, this character limit, would buy. Okay. To someone would buy. Okay. Here you go. Take a vote right now. Just take a moment. And remember, we're talking about a type 1 error. So this is good review right here. We're doing type 1 error. Oh, I need to do that. 2 hours ago. Type 1 error. Check on type 1 error. Let's see. Uh-oh. We got 67%. Only 11 people now. Okay, we're almost at a 50-50. So how do we do type 1 errors? Okay, so did we get it right? We're at almost a 50-50. Okay, so when we talk about a type 1 error right here, what do we do when we look at the null? So what do we do? This is why we practice it. So if I say type 1 error, you look at the null and you say what? The null is true. So what should she... And we're going to reject it, right? So, exactly. So I think we had more people than right, but the null is true. She should... That is the truth of the world, is that if we knew everything, and she'd find this out, she'd send the flyer out and the person wouldn't buy, because she's going to reject this null and say she has evidence that she should market to them. Does that make sense? Who's following me with this right here? The null is true. She should not market to them. That is the truth. But she's going to reject that and say, I have evidence that I should market to them. So she made an error. She sent the flyer to someone when they would not buy. Does that make sense? So this is the practice. And I want you to slow down on the next one. We'll do another one here. And I want you to look at the null and I want you to say, that is true in the type 1. Does that make sense? So the next one I think up right here, we'll do another one. But I want you to look at the null and say, like, that is true. So let's do another one right here. We'll do like a similar context. So let's say no festival in Knoxville. Festival in Knoxville. Okay. So we're looking to have a huge... the right answer was markets to someone with no interest, because she rejected the null hypothesis that she should not market. She thought she had evidence to market, so she rejected her null, and she thought she had evidence to market when, in truth, the person would not buy. So that was the right answer. Markets to someone with no interest. Thank you, Leo and Priya. Great questions. More Puppet Shark today. So now we're looking to see if we should throw a festival here in Knoxville. So what is the type 1 error? Top 1 error. And so throws festival. Wait, okay, wait. Doesn't not throw or not having festival when should have. Throwing festival when shouldn't. Okay. Which of these describes the type 1 error in this context? Would it be throwing the festival when we shouldn't, or not having the festival when we should have? So we're looking for, like, should we be throwing this festival in Knoxville? We really need evidence to throw the festival. So what would be the type 1 error in this context? And if you're waiting to answer, I want you to look at the null and say the null is true. The null is true. The null is true. So just and I love it right now. We're at 100%, and then it's gonna drop. And we're like, no, the null is true. So just tell me what is true. Just tell me what is true about the world. You know the truth right now. I know you would say, well, how do I know that? It's just like, this is a fact. What is a fact right now? I'm sorry to say it, but this is apparently the fact of this error. The fact of the world right now is what? When it comes to Knoxville and the festival, what? The fact of the world is what? The fact of the world is there shouldn't be a festival. I'm sorry, Knoxville. I'm sorry. I love Knoxville. I think we'd make a type 2 error. They both are. But the good news is what? What's the good news for Knoxville right here, Luke? Now, the fact is there should not be a festival. Like, apparently enough people aren't going to go or whatever. The fact of the matter is there should not be a festival, but we're going to reject that. Did we get our festival? Did we get our festival? Did we get our festival? Yes or no? Did Knoxville get its festival? We're going to have it anyways. So that's good news. The fact of the matter is we didn't get it. We're thinking of it from like a marketing aspect. Like, we're wondering how many tickets we're going to sell. So the fact of the matter is we should have not thrown the festival. We didn't make enough money. We thought we had enough evidence to throw the festival. So we said, sure, let's go with it. There's enough evidence to throw the festival. But we made a type 1 error and we threw the festival when the fact of the matter was we didn't make enough money. And we should have stayed with the null hypothesis of not throwing the festival. Is that making more sense right here, Priya? Like, going through these examples. So can you just find that is, well, can you find what the truth is? Then it's just the other one is what you do. Correct. Does that make sense, Leo? If the truth is that we should not throw the festival, then we are going to do the alternative. So that's accurate to say that if you know via these errors what the truth is, and there's another way of looking at it, but I don't want to overcomplicate it, which in the type 1, the first one is true, and in the type 2, the second one is true, but it doesn't go, I don't have a good rhyme for it. But in a type 2 error, the alternative is true. Now, don't, careful, that could hurt your memorization. But if you make a type 2 error, the null is false and we fail to reject it actually means the alternative is true. So that's another way, but don't hurt your phrasing up there if that's going to cause damage to, you always talk about the null. Just trying to keep it consistent. That's the mnemonic we use. In a type 1, the null is true and we reject it. In a type 2, the null is false and we fail to reject it. And these are like truths about the world. We don't usually know these things. Why would we know later on we shouldn't have thrown the festival? How would someone say, well, how'd you find out the truth? Well, because we threw the festival and we didn't sell enough tickets. So the reality was we shouldn't have thrown it. Now, interestingly enough, in a type 2 error, explain to me what the type 2 error is right here. The type 2 error is when the null is false and we fail to reject it. So exactly, we know by the prophet, right? So this is a false statement. So if this is false, then the alternative is true in this instance. So if the null is false, well, what are we going to do here? We're not going to reject the null. So would we find out that we made a type 2 error? Just think about this, just conceptually. Would you find out you made a type 2 error here? Would you find out you made a type 2 error? Would you find out? Would you be like, oh, I made a type 2 error? Would you find out you made a type 2 error? And we didn't throw a festival, correct? We should have thrown the festival. We'd probably never know that. Maybe you might say, well, maybe the other cities do really well, and we figure out we could have, we might have assumed, we might have evidence, we might have reason to believe we should have thrown it. But if we didn't throw the festival, we might never know that we should have. So on the type 2 error in this instance, you probably wouldn't know you made an error. Does that make sense logically? Like, the null is false. You should throw the festival. Probably. We probably would have sold all the tickets or something, but we don't know that because it didn't happen. But in the other example, in the type 1, we found out the hard way that we made an error. So you might not know the reality of what occurs. So sometimes you don't know when you make errors, but you are making them. Like in this instance, the null is false. We should be throwing the festival, but we're going to fail to reject the null and not throw it. It all depends. It all depends. Which one is more likely? Imagine imagine you got two doctors. We're using doctor examples right here. If we go right here and we say the null is healthy and the alternative is sick, please get a good doctor. Always have good doctors. I suggest Dr. Mike. I don't know who he sees or what he does, but he's a doctor apparently. But we got healthy or sick. So the type 1 error is going to be when the null is true. Null is true and we reject it. So a type 1 error is when the doctor says you're sick and you're not. Do you think there's doctors who tell a lot of people they're sick when they're not? Just go hypothetically on this. Do you think there are doctors who do you think there are doctors? There aren't? Do you think there are doctors who say, like, you're sick, it looks like you're sick? Well, and here's the problem. And they're probably, I'm not going all like conspiracy here, but doctors make errors, right? Do you think there are doctors who tell people they are sick when they are not? Not that they think they're not. I'm not saying this is not a moral judgment. This is an error in diagnosis. Does that make sense? This is an error in diagnosis. That the doctor says, we think you have this problem, but you don't actually have that problem. And then that would be the type 1 error. Where the type 2 error is, do you think there are doctors who fail to find that someone is sick when they are actually sick? And shout outs to doctors. They're doing a very hard job. This is just the problem with human error. And this is why there's medical insurance and stuff like that. It's just the problem with human error. And you have to know when these errors do occur. And this would be a type 2 error here. Do you think there are doctors who fail to find that someone is sick when they are sick? When they are sick. That'd be a type 2 error because in a type 2 error, the null is false. They're not healthy, but we fail to reject the null. So that's a type 2 error right there. Now, are either of these good? No. But which one is worse might be context. Like maybe, like if I told you, would you prefer, horrible things to say, but would you prefer to be told you're sick when you're actually healthy? Or would you prefer to be told you're healthy when you're actually sick? Does that make sense? Neither one is fun, and it's all going to be context dependent. Someone might say, well, I'd rather hear someone tell me I'm sick when I'm actually healthy because I'm healthy and my positive attitude is going to get me through it, and I'm just going to go out and do healthy things. When they tell me I'm sick, I'm probably just going to get even healthier. I don't know if it just depends. It's tough concepts right here, tough things to talk about. This is the medical industry, how it works. You don't want to do misdiagnosis. The goal of the medical industry is not to do either of these, but it does occur. Exactly. And then as Leo says right there, if they don't diagnose something wrong, it could metastasize and get worse. So you want to catch those things early. But maybe here's the argument against that, Leo. Someone might say, hey, if they tell you you're fine and it's something like that, maybe you're, for like the next few months, you're like living super happy and you don't have it weighing on you. Like it just depends, right? The problem is we're dealing with human perception. So to answer the question, which error is worse? Which error is worse? And this is why we had this conversation here, which is a lot of heavy topics. Which error is worse? Is the type 1 or the type 2 error worse? And which one is more likely? Neither one's, it just depends on what you could raise your alpha level, type 2, but it's not always, Leo. Maybe for you. It depends. Type 1, type 2 just depends on the person. Like which of those are you more, would it be worse to reject the null for you when you shouldn't? Would it be worse to not reject the null when you should? Depends on the person. It's purely subjective on which is worse. It's not like one is always worse. It's completely subjective. Does that make sense? Because you're telling me what you think about it. You're saying, I think it's worse to tell someone they're sick when they're actually healthy, or I think it's worse to tell someone they're healthy when they're actually sick. Both are not good. It's just all in a lot of heavy topics right here, but it's all just preference. Neither is good. And that's why there's malpractice insurance and stuff like that. And just like this, just imagine if your whole job, I can't imagine. That's why if I make a mistake with grades, I can just call the registrar and be like, hey, I misentered this grade. It's like happened like once in my career. Someone's like, you entered in a C and I got an A. And I was like, whoops, whoops. Errors are just bad. Exactly. So, and my errors don't really, hopefully don't have that big of an impact. I'm not doing life and death errors. Shout outs to doctors, like Doctors Rock. But they got a very hard job right here. Doctors Rock. Very tough job right there. Yeah. Stuff like that happens, right? Errors happen. Errors happen. That's a tough fact about the world. I had a few surgeries and stuff recently, and it's like you gotta so you want to have a good sample size of the person beforehand so that there's less. Oh, that's kind of good right there. More sample size, less type 1 error. So if your doctor has more larger sample size of observations, less type 1 error. So it makes sense right there. That's just how the world works. Well, we'd hope less type 1 errors. We can't promise, but the world should kind of weed out people who are making a lot of errors. So power confuses me, and then let's talk about power right here. How I get errors works, how to identify each one, but the power and beta is all a little, you got it. Let's talk about power. And they'll probably end off right here. Power conversation. Power conversation. Viewing power. Okay. 1 minus beta is power. So what is power? Power is, simply put, 1 minus beta. That's the mathematical equation. The definition for power is ability or probability we correctly reject the false null hypothesis. Power mathematically is not making a what. So you have to know what beta is right there. Beta, which is B, is a what? So this is what power is. It's the complement of doing this. The likelihoods one assumes. Not quite, Leo. Closely. I wouldn't say assumes the correct null. You want to reject the false null. That's what power is. Be very careful. It's got some key components. It is a probability. That's key to know. It's a percent of time we do this. It's a percent of time we correctly reject the false null. Those are kind of the 3 key phrases you really need to be talking about power. It's a probability, so it's a mathematical probability that we will correctly reject the false null. And so think about this. It's as though you know the null is false. And if the doctor told you, we're going to do a test, but it's not very powerful, and the null is that you're healthy. I don't like this. Let's do this right here. Let's do a different one. Okay. Not cheater. Let's do the cheater example. It's not fun talking about health. It's not fun. I'm in the teaching industry for a reason because I don't do health stuff. Okay. Most health I do is go on my Pokemon Go walks. So now, if I told you this test is not very, very powerful, I want you to think about what this means when I tell you the power of this test is equal to that. What does it mean that the power of the test is equal to 0.01? That's the probability it correctly rejects the false null. To correctly reject the false null would be to find what? To correctly, as in when we should, reject this and say we have evidence for this. To correctly reject the false null means that we are finding what? To correctly reject the false null. Like the null is false, so we're correctly rejecting it. We're not making an error. We are finding what? So this, what does that mean conceptually? To correctly reject the false null right here means we're finding cheaters. Does that make sense? Which means we find the cheaters because we've correctly done it, and we know via this that we're not making a type 2 error right here. We're not making a type 1 error also. The power of the test is the ability for it, or the probability, because it's a mathematical probability, for it to correctly reject the false null. So what would you tell me about this test? Only 1% of the time does it correctly reject the false null. This test is not very what? Only 1% of the time it correctly rejects the false null. It's not very what? Only 1% of the time that it does what? It correctly rejects the false null. It's not very powerful. It doesn't have the ability to find cheaters. So this test just wouldn't be good at finding cheaters. It's not, and it wouldn't be very useful then. Yeah, we would say, well, why do we run this? It really doesn't have the ability to find cheaters because that's what power is. The test is not very powerful. So what could we do? Well, beta is a type 2 error. We're trying to decrease beta. And the three things that control beta, so controlled by three things. The three things that control beta are going to be, does anyone know any of them? Sample size, which is just n. And then we have here the alpha level, which is it's an A or so, like an alpha for an A. And then also that is, let's just sample size. Alpha level is type 1 error. That doesn't look good. Alpha level, which is, yeah, type 1 error. And then last but not least, effect size, which is distance from null and the truth. This is just amount taken in the sample. And then distance from null and truth. So, you know, I mean, I just try talking real right here. When do you think it's easier for me to detect cheating? If a student looks at a project for 1 second and like glances at it, because it's kind of, I mean, like if your friend's like, hey, giving you suggestions, but if you're like, let me look at your project. Okay. You shouldn't be doing that, right? Just saying. Or if a student takes another person's project and just directly copies it, when do you think it's easier for Brian to detect cheating? Like if someone just changes the name on a project, when do you think it's easier for Brian to detect cheating? If someone just looked at someone's project, which I can't probably tell that. I mean, you shouldn't do that. I'm not going to try to hunt down everyone who's like looked at someone's project for a second. That's something I don't have the ability. Because what are we changing from going from looking at someone's project, like in like, not like, oh, that's you, not like you saw it out of the corner of your eye and be like, oh, that's your project. But you're like, let me read your project before I do mine. Don't do that. It's the effect size, right? So the null hypothesis is that you're not cheating, right? The null hypothesis is that you're not cheating. So tell me, the effect size, if you think the null of not cheating right here, so not cheating, and I'm not hunting down the people who have like seen someone's project for a half second and looked at it. It's not what I do. But if you just like glanced at it, but as soon as you start copying part of that project, as soon as you get a copy of it, like and you start copying it, what happens here? What's growing right here? What is you have a larger effect size. We can only estimate the effect size right here. So we don't really know the truth because you'd have to know the truth right here. So like assuming that someone didn't cheat, if I see that the projects are identical, but just like the name is different, that's a large effect size I am viewing. Now, I don't know what the truth is, though. I'm just estimating the effect size. You don't know what the truth is. Like, it looks to me like the truth is that they super duper cheated, right? But it'd be very hard to know that someone did something very tiny. Does that make sense? Like, this is a tiny effect size. Does that make sense, Priya? The effect size also could be thought of in the medical industry. If you walk into the doctor, it's usually it's effect size numeric value. It can be quantified for some examples, but conceptually speaking, and we do this sometimes as a definition on the test, the effect size is the difference from the null and the truth. So sometimes it's just learning it definitionally. So always know the definition, and then try to get the deeper learning. Think about an effect size. Like the doctor doesn't know exactly how sick you are, but when would the doctor think there's a larger effect size? When someone walks in, they're like, I don't feel so well. Or someone walks in, they're just like passed out. Someone walks in, doesn't walk in, right? Someone's brought in passed out, or someone walks in, they're like, my throat's a little scratchy, like a little tingle in my throat. Just, just a little mucus doing, just a little bit. And the doctor's like, well, like it looks like you have a little, like, you could just be healthy, right? Like, I don't know. I'm not viewing something large here, but then someone comes in on a stretcher, that's a larger effect size. So the null hypothesis, which would be healthy in this instance, you're very close to the null, but then when they're passed out, there's a bigger effect that we are assuming. We don't know what the truth is, but you can kind of take a guess at it. Does that make sense? Like, I don't know, like, and this is the hard part of being a teacher. Do you think I ever know 100% certain someone cheated? Like, just go, like, I am not omniscient. I do not have the ability to see everything that happens. Do you think I would know with 100% certainty someone cheated? Like, they might say, well, like, why would you ever accuse anybody? It's just because I didn't see it. Like, unless I literally like see it, even then you might say, well, how do you trust your own faculties to view things? How do you know you're not just a brain in a vat? I'd say, oh, don't go solipsism on me. Maybe some philosophy people are here. But I would have good evidence, right? At that point, I'd have good reason to reject the null. At some point, and this goes to the other concept, at some point, this is going to cross my what level? At some point, this threshold of what I'm observing is going to cross my what level that I'm willing to make this sort of error for. At some point, which I always have a set kind of boundary for this when I'm looking for cheating, it's going to cross my alpha threshold. So at some point, I'm going to say like, yeah, and I'll tell you, I do it via plagiarism checker, and I've got a threshold by which I contact students. And I will say this, I set that threshold pretty high. And Brian is probably sure he's made a lot of what I would be very certain, because I've been like, Brian is certain he's made a lot more whats than whats. In Brian's quest to stop cheating, I am very certain I've made a lot more type 2 errors. I am very certain. I literally sometimes find like the 15 worst, and so just get everyone, don't do this. Get everyone to cheat, and then Brian will just go for the worst. I find the ones that are the ones that I'm like, this is really bad, and that I feel there's no possible way. And then there's ones where I'm like, not that I think they didn't cheat, but I'm just like, it's a lot of work. Every cheating case, I would say, takes about 4 to 5 hours to deal with, which I'm going to deal with each one. I'm going to deal with, and thank you for everyone it's a lot of time. And so I don't want to find them, but I do. And then my life is fun. Exactly. It's not fun. And thank you to anyone who have contacted. It's been, some people have just come out and tell me what happened. And I will say that it does help you. Anyways, if you ever get contacted by a teacher, just be totally honest. Now, don't admit to things you didn't do. Just be totally honest. So if you like go over this threshold, then I'm going to contact you. And at this point, I don't think I've made a type 1 error, because I have a very what alpha level. Now, be very careful. Brian uses a very what alpha level. Brian does not think he's making type 1 errors here, because Brian is using a very what alpha level. Be very careful. Wait, Leo. It looks like that via the graphic. That's why I said be careful. I'm using a very, very low alpha, because if you lower alpha, if alpha is lower, so lower alpha means higher beta, right? So remember how we said Brian's making more type 2 errors? So Brian is probably making more type 2 errors. So Brian is losing a lot of what in his test? And just think about how this corresponds to what we're talking about. Brian has now lost a lot of what in his test by lowering his alpha. Brian is losing a lot of what in his test right here. My brain is breaking on how to do alpha. Brian is losing a lot of power, because 1 minus beta is power. So it's a lot harder to me. It's a lot harder for me to find cheaters. I'm making it harder on myself by using a lower alpha. By having such a high standard, which equates to a lower alpha, I'm rejecting the null less often, and my test is less powerful. I'm not able to find cheaters as well. In exchange for that, I'm making more whats. Repeat it again. By lowering my alpha and making it harder to find cheaters, I'm losing power, and I'm making more whats. You will say, Brian, you shouldn't make these. I say, well, I'm not perfect. I'm going to make more of these, and this is the way I do it, is I prefer to make more of these in my quest to not have people cheat. If I'm going to make errors, I want all my errors to be what? And I truly mean this. I want every error I make to be a type 2. Now, I don't want to make all type 2 errors. I'm going to move forward on the ones that I really think I can reject the null for. And so my test needs to be powerful. And the way I do this is I use a plagiarism checker. And the plagiarism checker has a very large what? Sample size. So luckily, I've got tons and 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 tons of data. So I am getting some power on this. And I'll say this, you know what's interesting? Down to only 10 watching. Do you think it's easier to detect cheating on project 1 or project 2? So I want you to think about the sample size question here with project 1 or project 2. And why would it be easier to detect cheating on one of these? Which one of those do you think it's easier to detect cheating? It's longer, right? So it's a larger sample. Do you know what's the hardest things to detect cheating on? What's really hard, and please don't cheat. If you're seeing this in the future, I'm not suggesting cheating on these, but the hardest thing to detect cheating on for us is what? The hardest thing is not project 1, not project 2, but your what's. This is the hardest one for us to detect cheating on. And it's due to the small sample size. So it's very hard to detect this. It would be your visualizations. Exactly. So if you notice here, the visualizations are the smallest n. So when you have a much smaller n, it's harder for us to detect cheating because we just really don't have a good enough sample. But as you go here to a larger n, it's going to be easier. So this is when n gets larger right here. It's just really hard to make an accusation of like, oh, you cheated on the visualization. Exactly. And they help a ton for the project. Like you're basically then doing that for the project, doing your confidence intervals, doing your things. That's our goal, is to kind of, when you get to the project, it's not so bad. I hope it wasn't. But so the sample size right here, and these all have this concept. We just usually write out our thing right here, that every single one of these, whether it be sample size, whether it be alpha level, whether it be effect size, if any of these go up, then beta does what? If any of those go up, like if you have a larger sample size, a larger alpha level, which means you have a higher type 1 error, if you have any of those increase, beta does what? If you increase any of those, beta does what? And this is the review of it right here. Beta decreases, exactly. You're welcome, Priya. Yeah. And then by decreasing beta, well, then power is 1 minus beta. And power is, power gets the complement. So it's not making a type 2 error. So power would go up. So if you increase your sample size, increase your alpha, you do not control effect size. Effect size is the only one you do not control. You do not control the distance the null is from the truth. It's just the fact of the world that you don't control. You can control how much you sample, and the researcher picks the alpha level right there. And the alpha level is type 1 error, and the beta is the type 2 error. And that's some good notes right there, just understanding conceptually. And just my biggest suggestion to people is try writing these things down, try communicating them. The best way to learn stuff is to just try to write down these things I do and then communicate the ideas that all of these are negatively correlated with beta. Do understand that alpha and beta are not complements, but alpha is inversely correlated with beta, and alpha is positively correlated with power. But what are people thinking? We'll probably head off here in a second. Good 2.5 hour stream. So what would a test question look like? A lot of conceptual stuff sometimes, like maybe if you look at like I think there was some questions on Canvas content, right? Someone made a document. It's posted to the Discord of all the Canvas content questions. So great job on the Discord. People posting that. You're allowed to, I have no problem if you write them down and practice them. We should probably think of more Canvas contents. But, yeah. And I think I'll talk to Terry and I'll be like, I really think Canvas content should be open note. That's the point of it. Like my Pearson's open note. To me, Canvas, I don't see why it says like, because it's just taking we don't have the things on to monitor or whatever. It's just open note to me. It's all besides the hypothesis test. Do you want to do one more of those to end here, Leo? But to me, Canvas content's, open note. Just, know how to practice them and know how to understand them and just keep working them until you understand those. And that's a good view of what's on the test. We purposely made them so you could see test questions, because before we had Canvas content, which was my idea. I came up with Canvas content. It's not open right now. You can view your old ones. You'll rewatch Awesome Leo. We'll probably do another stream here probably tomorrow. Day of test, we might get a lot of people. You never know. But yeah, any last questions here? We'll head over to the main screen. I need to go eat some lunch. I don't even know what I got in the fridge. Can we do question 2? Yeah, of course, Luke. Thank you for being here. We'll turn on some music. Let's go do that. And do remember, I need to, I should go to the grocery store today. It's the new summer Red Bull, is it? You're welcome, Barrett. Thank you so much. Exam early and did the form. Yes, I'll get it done early for you there tomorrow. Maybe noonish or 11ish, noon or 11. I don't know. I'll play my daily Binding of Isaac run, and then question 1. Question 2, part 4. Question 2, part 4. Practice test question. Over to the main screen. Okay. Haven't had it either. I'll try to pick it up. I'll try to remember. Leo and Priya trying to jump to the lead there. Okay. So for practice number 2, part 4, check it out. This is question 2 right here, testing a proportion. We're going to go through it. We're going to do it right here, and I'm going to try to do it a different way than I have it in the video. But do remember I have a video for each question. Suppose the researcher wishes to carry out... right? Is it write the null and alternative? Is that the one you're working on right here, Luke? Write the null and alternative? Didn't mean to show it right there. But is this the one you're working on right here? Write the null and alternative. Question 2, part 4. It's part 6? Oh, part 6. Oh my gosh. What level of alpha did you use when you used your above technique to make a decision regarding the null hypothesis? Part 6, awesome. Oh yeah, I can't read. I think you properly did it, and I just can't read. I bet you did. Okay, so when you think about this, we can do, and they go through here and do a full test and confidence roll. We should see right here 93%. So when you use a confidence interval, this is part 6 right here we're talking about. We need to grab this. Because the way tests work, and apparently we're testing a certain value. I don't know what value it was, but a confidence interval has a similarity. I'll put P naught right here to a what-tailed test. Confidence intervals have a similarity or a connection to a what-tailed test. A confidence interval has a connection to a what-tailed test. A confidence interval has a connection to a what-tailed test. Mubot's going crazy. A confidence interval has a connection to a what-tailed test. The two-tailed, correct. The confidence interval has the connection to the two-tailed test. So if you look at this portion right here where we write out the null and alternative, so you go down to here, we write our null and alternative a little bit later on. Where's that null and alternative? We are using the two-tailed alternative. So the two-tailed alternative here, and there's the hypothesized value of 0.75, so that's P0 right there. So the way to think about it is if we are using a 93% confidence interval, the 93% confidence interval means there's 93% shaded inside of here. So what is the corresponding alpha level? Remember, this is the two-tailed test, which shades both sides. So the does not equals test, and I usually do the arrows that way, the alpha level corresponding right here. So the alpha level is equal to what? Yeah, that is correct, Leo. Wow, my brain didn't work. That is correct. Great job, Leo and Priya. And you'll notice that these two values add up to 1. Those two values add up to 100% of the curve right there. So I probably do, right? I'm about to tell you you're wrong and be like, oh, that's correct right there, Luke. That is correct. That's the way it works. It's the corresponding test. Good questions. And I hope this visual helps. It helps to see things rather than say them. That's something I've learned is drawing it out can really help with understanding it. And the hypothesized value, according to this question, P0, the hypothesized proportion is 0.75. A lot of this comes down to notation. No worries, Luke. That's why I was like, let's just do it. Let's just do it right here. They're doing things awesome. Well, great work, everybody. I'm going to go grab some food. We'll be back, though. Until then, bye for now, everyone. Bye. Grab some food time. Woo! Wrong thing on the screen.